being recorded.
All right, welcome everybody. My name is Ben. I'm the current president of the Robotics Society of Southern California. I'm here with my officers and our members here in person and some online. Welcome everybody. Today we have two discussions. The first one, we're going to start off with Alan and his amazing talks on AI and all the amazing things that he is doing. After that, we're going to follow up with Jim. After the two talks, we usually take a little lunch break, and then we come back to the amazing show and tells, where anybody can show us what they're working on, give us a short, maybe 10-minute presentation on what they're doing. So stick around for that. If anybody has show and tells, please let me know so I can add you to the list, online and in person. Okay. All right, Alan, you want to take it away?
Oh, close to stable screen sharing, just a moment. Share settings. Why is it that every time we do this, I totally forget there?
Because they keep changing the UI. I know what.
Let's go with that.
Why do they do that?
All right, just a moment. I'm looking for the share options.
Share. Oh, share options.
Post tools for share. It's always where I don't look. All right, sorry, I'm looking for the share button. I share all participants. All right. All right, so next month when I forget again, everyone in the audience, it's under the pop-up and host tools for share, and who can share all participants. All right, got it. I keep promising people I'm smarter than I look. All right.
Because you're persistent, naturally. It's already happening.
Boy, where are you when I need you most? Okay, all right, let's do a little bit of rearranging here. So for anyone keeping score, I am currently on Lloyd version 4, and a bunch of stuff has happened. But it all starts with the large language model, with the AI. And right now, I am fortunate to be able to run the Quen 3.5 122V model A10B. What that means is that the total model size is 122 billion parameters, which is huge. But because they do something called mixture of experts, meaning that is split among a bunch of smaller models with a model router, each submodel gets trained on a subset of questions. So each composite model is about 10 billion, more or less. And so you get most of the smarts of a large model, but it's even a small one. And on its own, you know, you can look at things like the composite score among different benchmarks. And the question becomes, how do you gauge the performance of each of these models? Now, back in the olden days, 3, 4, 5 years ago, it was a simpler time where you just measured knowledge. And then those benchmarks started getting saturated. We started coming with the concept of agents that could do things and follow directions and call tools. And that same question of which model is the best becomes very subjective and hard to measure. And where this came up for me, I'm actually looking in two different directions. Is it possible that smaller models are just as performant? And on the other side of that is, do I want to impulse buy additional graphics cards to run larger models, right? Some way of rationalizing that decision. And so I've settled on this artificial analysis site only because they seem to be a pretty good aggregator of benchmarks across models. And it makes it pretty straightforward to compare the model's performance against these benchmarks. So let's take a quick look. So we have two basic sections. There's like a conglomeration, a composite score, an intelligence index, then a coding index, and an agentic index. So more or less an overall, how does it do at coding and how does it do at agent stuff? So we've got these combination metrics up on top, and then a series of benchmarks down below that we can start to compare them. And if we compare, let's say, for 3.5, so the exact publisher of the model I'm using now, let's look at the largest model they have available. And then let's look at the next two smallest ones. So there's a 27B dense model, so there's no mixture of experts. It's going to be slower. And then there is a Quen 3.5, 35D reasoning, right? So just looking at the performance of those, we're talking about four models in the same category. 397B, and then the 122, the one that I'm currently running, and then a 1/4 size MOE model and a dense 27. And you can see for the top three, the scores are almost a rounding error difference. There is some appreciable difference in the composite, but not a whole lot, right? Definitely not enough to justify buying 3 additional graphics cards to run this locally, right? Just based off this composite score. In coding, the difference becomes a little bit larger. Let's say between that dense model and the large localish model. And then oddly enough, my 122B model has the same score as the 27B model, which is weird. It's a larger model, but it looks like that coding expert being 10 million parameters, puts it at parity with the 27. And then agentic index, the ability to follow directions, to plan, long horizon tasks, tool calling. These are all effectively the same score, and then that previous generation 35B model drops a little bit. Okay. And that is for 4 models that were just published a few months ago. Now, let's take a look at some of the things.
And that can fit, the lowest one there can easily fit on good graphics, one good graphics.
Yeah, and that's the other thing that's super surprising. When you look at that spread, you're comparing a 35 billion parameter model to a 387 billion parameter model. And the difference in performance isn't that great. And it's a testament to all of the incremental changes that have been made to model training and fine tuning. A whole bunch of small improvements results larger improvements. And over the past year, definitely over the past 6 months, you're seeing, and calling a 35 billion parameter model a small language model is a little bit of a stretch based on where you're at with your hardware. So if you've got a 3090, 4090, 5090, that'll fit on your graphics card, right? Now, if you're not fortunate enough to have one of those, then it's still out of reach for running locally. But within the reach of a spirited enthusiast who wants to, drop some serious cash into that graphics card.
What's the 12210? The 12210. It's 10 at once, right? Mm-hmm. So can that fit on a? Where do you run that on?
What's the minimum? Not. You need larger hardware than a 5090 for that.
Because the 122 doesn't have to stay in memory, right?
Oh no, it does. Yeah, it all has to stay in memory. But then if you're looking at like a DGX Spark, or Apple Silicon, the Apple CPU, GPU with shared memory with an MLX quantization, you can run these models on your Apple laptops, on your Mac minis. It opens up local models in a way that just wasn't possible before. They're changing the name of the game. So I myself am keeping an eye out for when the M5 Mac minis become available, because it's a really compelling option to run models that it's just not realistic to afford the hardware, a dedicated GPU with the VRAM. These 5090s are going for like $3,500 right now. So like if it's between that or picking up like a $700 Mac Mini, and you're getting most of the performance, and goodness help NVIDIA if their GTX Spark performance with their 128 gigs of shared memory, how that performance compares to an M5, I'm very curious about. The M5 laptops are out now, so. So now when we talk about local models, there's realistically to run locally, and then realistically with hardware to back it up.
If you have the 64-bit Jetson APX Orin, that can run the 122A10, but is it fast enough at 4-bit or?
Well, the Orin's a 64 gigabyte device, so even at Q4, you don't have enough shared memory to run the one.
It says you can on.
At a lower,
requires heavy quantization.
at a lower quant, maybe
1.58. It says 4-bit. Well, but that would be very slow anyway, right?
It would be. But
Slow machine.
the other one that I'm looking at, so when we're talking about model performance, the Alibaba folks just recently released a set of new models, Qwen 3.6. And let's look at the scores compared to my favorite 122 from 3 months ago to a much smaller model where they've improved their fine tuning and some other stuff to see how it performs. And this is kind of where I wanted to start this conversation. Benchmarking is hard. You wouldn't think that it's hard, but let's compare our intuition to what we're seeing. Now, first off, as new models come online or trained and fine-tuned, you have the unintentional contamination from existing benchmarks available on the internet, and you have intentional benchmarking. And I'm 100% certain, based on culture and previous, that Alibaba is intentionally benchmarking their models, fine-tuning their models to maximize their performance on a benchmark. Will that result in some additional capabilities for free? Maybe, maybe not. But you have to keep that in mind when you're looking at the scores. Is this a benchmark where the questions and answers are available on? Some of them are. Is this a benchmark where the questions are available and the vendor is capable of looking at those and generating training data to be able to maximize their performance on it? Also, absolutely yes. So when we look at this, my favorite 122, check this out. A more recent model, 1/4 the size, scores a point higher, effectively the same score, right? Isn't that interesting? And then the 2070 dense model, which from people on the internet and YouTube, they claim is a really strong contender, it is appreciably higher. So when we look at coding, we see a similar spread, and agentic index, a similar spread. So what's a guy to do, right? So what does that mean, that I should move to the 3.6 A3 model of 2070? I'm not sure yet. And when you look at the different benchmarks, and you have to dig in and then understand what the benchmark is, what's its internet presence, what it represents, just to drive home the point that benchmarking is hard, and that people in the know, they say, well, benchmark it on your own workloads to find out for sure. So, okay, so if you have things at the ready that you can set up as a test harness and run them, that's the only way you can know for sure. All of these are hints, but you won't know until you actually use it. Am I considering moving from the 122B model to the 35B? Yeah, actually I was running it for a couple of weeks and then I switched back. So you have the benchmarks, and then you have the intuition. When you're looking at the parameters in the model, what you're looking at is how lossy is the compression to compress the world's knowledge into those weights. And that's really what it is. You can take any one of these models and ask for questions and answers in any common language. First line treatment for hairballs in cats. What are the top three arthritis medications for dogs? At what point did we go from 9 planets to 8 planets in the solar system? And it knows it, right? The things that were novel to us 4 or 5 years ago, we take for granted now, even in these smaller models. So the devil is in the details. Is the 122B model has to be smarter than the 35B because there's more parameters. That's muddied up by the process of fine tuning and that virtuous cycle of finding applications for large language models, which then go into the training data to train and fine tune the next generation of model. Go back to my first point, benchmarking is hard. So I'm actually considering setting up a new version of Lloyd with actually both of these models because they'll both fit on my card at the same time. Is what if there's a version of Lloyd where I have the 27B dense model, which will be slower than the one I'm running, but apparently is better at coding and instruction following. And then pair that up with maybe the Qwen 3.6 35B model, which will be even faster for daily interactions, right? Just one of the things that I love right now, and it's one of the reasons I haven't gone back to work on Alfie, is having all of these things available. There's such rich surfaces for exploration that you can just do on a whim. Now you've already heard it's been 5 months since I've written code. Sorry, boss. You didn't hire me to write code anyways. but the in one of the Claude's been very busy this week on the internet describing their tools and how much better they are than is that it's no longer a case of trying to figure out what direction you want to go and then writing the code. There's no reason to wait. If you're wondering if option A or option B is better, just have your coding agent write both out and test it. Have it write the testing script. Have it write the evaluation. Say, hey, flash out both of these options. Write the testing harness. Go ahead and run some tests and come back to me when you're done. And I can guarantee you it'll complete that in less time than any number of people can come to a conclusion by debating the relative merits of architectures just based on, vibes and previous experience. It is a wild time to be alive and involved. And when we get over to Lloyd in a little bit, I have to ask him how things work in the code, because what literally happens right now is I'll find something cool on the internet that says, oh, we figured out some knowledge graph or Karpathy's LLM wiki or any one of a number of things. I don't even have to take the time to go through the video. I grab the URL, I paste it in Lloyd. I'm like, Lloyd, pull the transcript and give me the highlights of his talk, and then tell me if there's anything that we would want to use in our own architecture. And a minute later, he gives me the summary that I can read in 30 seconds. He gives me his reasoning. He tells me what we might want to do, and if it makes sense, and either I tell him to wrap it up in a backlog item, or maybe we'll do that right now, or okay, that was a no-brainer. That's generally how I'm taking in breaking news things in AI right now from the internet. Lloyd is intermediator to tell me if it's something that's worth my time. And honestly, almost all the time, he makes a judgment himself. I don't think there's been a case where he has brought something up and made recommendations that he thought were worthwhile, and I disagree with them. It is absolutely wild. So to get back over to the models, I'm considering different arrangements of models. And the difference in scores really isn't that high, but then is it high enough to make a difference for me? Now, on the other side of that, I'm always looking for excuses to waste more money on graphics cards. The other one that I'm looking at is Minimax M2.7. Minimax M2.7 is a 240 billion parameters. So it has twice the parameters of my current favorite model. And I'm like, okay, well, before you impulse buy it, how much better is it going to be? And it gets back to how difficult benchmarks are. Check this out. So in the artificial analysis index, between where I'm at right now, it does appear to be noticeably better. Let's say 42 to 50, whatever these composites. Let's look at coding. In coding, the difference is even more pronounced, but not twice as good, right? Like that previous intuition of a model twice as large, it no longer applies just because of how smart even the dumb models are, or the smaller models are. In a geometric index, oddly enough, that 27B dense model does score a few points higher than Minimax 2.7. And going back into the scores, terminal bench hard, terminal and coding use. My favorite model is scoring almost 10% less than that. Okay, well that could potentially be interesting. Humanities last exam, it tests knowledge and reasoning. And in that, my 122 model stacks up. And the stack is about what you expect from smallest to largest in terms of reasoning and knowledge. GPQA Diamond, that benchmark is effectively saturated for a couple of different reasons. So when you're looking at like 84 versus 87, and if we were to throw on Opus 4.7, but large one or GPT 5.5, it would score a few points higher than, right? But in terms of local models that people have any chance of running without taking out a second mortgage, it's effectively saturated. So as of right now, I'm still on the 122 view. I feel pretty good about that. The difference in scores to throw that much money at it for a few percentage points higher, it doesn't seem to be really worth it. And to drive the whole point home is like, how smart do I need my personal agent to be? I've since completely separated out the Claude Agent SDK and the Opus 4.7 and Sonnet model from Lloyd. Lloyd runs completely locally 100% of the time. And so that in V3, where I would use Lloyd to work on Lloyd in real time, that's no longer the case. I use Claude Code to work on the infrastructure stuff. And then, inference and AI agent stuff, perfectly serviceable on the 122. And it's working out really well. Every once in a while, I'll test the waters to see what I can trust them with. And I'm constantly surprised on both sides. Things I didn't think he'd be capable of that he does, and the other side, simple things that he just didn't get. Last week, I had Lloyd with the local model code a Chrome extension that gives me a button in my Chrome that when I click on it, it sends the URL back to Lloyd to run the analysis and generate a note to remove some inertia. Instead of having to, because it's so much a drag to copy and paste between applications, I just want to have a button on it. And he did it. Yeah. Like little things like that, right? That wasn't my idea. I heard someone on a podcast describe it. Like when the only inertia between what you need and writing the code is just remembering that you can have an agent do it for you. You can write code for trivial things and it just works. And I'm still learning that on my own. I'm limited by my ability to imagine and remember that I can have a coding agent solve the problem for me. Yeah.
Did he buy your parking today?
He didn't, but we're almost there, and I'll show you why towards the end. It's cool. And the challenge is, this is 100% my fault, is that when you're building robots, it's the same thing in building AI. The question is, well, what does it do, right? And we're always like, oh, this year we can finally have answers on robotics. So I've been so engrossed in the mechanics of agents and learning how to work and trying out new things and changing the framework 4 times that I keep losing sight of it's supposed to be my personal assistant that does things. And I've got a question for you guys towards the end. You guys can help me with on that. And that leads into the second half of my talk, which is a feature I'm calling Inner Voice. For those of you that saw the movie iRobot, poorly adapted as a Bob model, they bought the rights to the iRobot series of small stories. And then all they used was the concept of the robot, the positronic brain, and 2 of the characters' names. It has nothing to do with the books. And aside from some glaring plot holes, in the movie. It's an entertaining movie. There's action. Will Smith before, things got weird with him. And one of the main plot points is this, if you haven't seen it yet, spoilers. Sonny is at the center of this whole movie, and there is this clip in the middle where the doctor, the professor, is trying to figure out what's going on, and she discovers that Sonny has two brains. He has his primary brain, positronic brain, in his head, where all the other robots have, and then the other scientist put a second brain in his chest. Right? It's just a plot device. And this had nothing to do with anything that Asimov wrote. Asimov was all about finding the logical errors in the three laws, like more subtle things. Nothing as ham-fisted as putting in a second brain. But
He's got a heart.
Huh?
He's got a heart.
Yeah,
Yeah.
All of them.
that's exactly it. Yeah,
The brain,
yeah. So that was the plot twist, is that he has the positronic brain and the three laws, but then he has a second brain, so he can choose not to follow them. And
Yeah, because they think it was suicide by robot.
right, exactly, suicide by robot. And so when I've been working with oh, I'm definitely in the right place. With the stuff that I'm working on and with agents, when you throw a frontier model 1.6 trillion parameter or whatever they are agent on, it can follow directions, it can keep train of thought. It is magical when everything's working correctly. When you get down to the smaller models, it's less able to do this. And even in Claude Code or with Opus 4.7, I've seen cases where it just stops. It's in the middle of doing something, and then it just stops processing. Or it times out, or it stops before it was done. Just little things, right? And even on Opus 4.7 and the Lloyd harness, it's a thing that happens. So what this started with was, well, what if I could have a second model that could just keep track of the first model and then nudge it whenever it stalled, right? That was the genesis of Intervoice. And after I had that shower thought where I connected what I was trying to do with the movie, well, I can actually run multiple instances of the model at full speed, right? So there's very little performance penalty for doing this. So let's explore this. What if we had a second model that I called Inner Voice because I thought it would be cool. And Inner Voice had a couple of jobs. Actually, we could close that off so he doesn't accidentally listen to me. He, first off, if you notice a stall, nudge. And now let's explore this, right? Let's look at what would happen. Let me find a good one. So here, let me dig in this a little bit. Still, let me see if we can. Oh, yeah, okay, all right. All right. I don't know, it's a little, let me try one more.
You can hide your little screen, maybe.
Yeah.
Up at the top there. It's funny in the movie because you weren't supposed to draw it manually.
All right, I'm sorry, I can't figure out how to get that. So to kind of skip to the end, here is an example interaction where the primary model is interacting with me, and the IV model, the Inner Voice model, is keeping track. And it only has 4 tools. It has complete access, and it's fed everything the primary needs to. And it only has 4 tools. It can ask for clarification. It can nudge. It can do an e-stop if things are going off the rails. And it will confirm success. And it keeps track of and it has access to my subliminal injections. Everything that's fed into primary is fed over. And this is the tail end of a conversation from last night where I was curious about, I was trying to get it to feed into its knowledge base about 1X Neo and a Figure 03 robot. And so in the last interaction, I'm like, hey, have they said when they're available for to purchase? The context then goes to Inner Voice, and Inner Voice sets up a couple of things to make sure that it's on task. So this is its version of understanding what needs to happen. Things to look for that indicate that has happened, that it's done the thing, and some out of scope. So as it goes through and it does its thing, it evaluates every tool call, everything that it does, and it looks for if it's keeping on track. And in this conversation, there were 5 index. There were nudges where it stopped before answering the question. And in this case, it seems to work. And the reason that this works is from an intuition that some of us are getting from working with the model. Is that if you ask a model to do one thing, it is going to rock it. And the sliding, the border changes in every term. If you ask it to do 10 things, depending on how big the model is, maybe it'll do all 10 in order, and maybe it doesn't. And depending on the harness it's attached to, if it has the ability to capture those steps in like a to-do right and then check those off, it helps a little bit. But sometimes it doesn't work well on a smaller model, and that's what I'm exploring here. This isn't a done thing. This isn't a foregone conclusion. I'm exploring this in real time with you guys. Well, how could a second model that's the exact same model as the first model be any different? Well, my first model is working on solving the problem, and my second model is focused adversarially on making sure it stays on task. Yeah.
So it's like the ultimate critic first. So that's kind of neat. It could, I mean, maybe it'll work out like you said, because it's a single track mind critic, but you could probably afford a better model. So let's say you have, on occasion, spend a little bit of money on cloud or something. There should be a real low token overhead on this, because it's looking at these things, generating a few tokens, saying, yep, nudge or whatever. So it might be cheap to run a better model to do this occasional nudging if it turns out that it's.
Yeah. These are all areas that are rich for exploration. We were talking about that 35B versus the 27B model. If I load up both models at once, what if I made the critic one versus the other? The thing I'm really looking to solve, to prove, and this is just an intuition right now, like there's no guarantee aside from the occasional nudge this makes any sense at all, is what if running the model, whatever your given model is, twice in this primary and inner voice pairing, in some benchmark that isn't contrived, but an actual real world benchmark. What if this allows that model to benchmark higher than it would alone, right? This is a hypothesis. It hasn't been proven yet. So what if running this keeps whatever these benchmark scores in line with the 397 billion parameter? Meaning you can run a pair of models cheaper than the larger model. Yeah.
Do you need a pair of models? Because you just run the same model with a different prompt.
You could, except in this situation, we can run them in parallel, because my card will actually, with very little, but yeah, you can very little, like serve context go back and forth at twice the speed. Yeah.
Is there an advantage to running more than 2 models, like specific models that are optimized for specific tasks, like getting like maybe like 10 or 12 going at the same time?
Possibly, and that already comes up in a couple of different ways. And so to wrap up my previous point, like what if running a pair of 9 billion parameter models gives performance equivalent to the 120 right? Like this is what I want to figure out. And the challenge is, I won't bore you with any more benchmarks. It's like there aren't any benchmarks at the ready that we found that allow us to test this out. So it's just a working hypothesis. And or run 235Bs equal to 122. It's possible, yes. Is it plausible? Not sure. But the Lloyd already does run multiple workers in parallel. there is a rich set of autonomy tasks that he runs in the background with various tasks of knowledge management, research, filling in the blanks, pruning, greening almost. And with how I have workers set up right now, is that up to 4 of those can run at one time. And when it's doing some forms of research, it'll actually spawn off multiple sub-workers to pull the research for the web pages and subtasks as well, that whole scatter gather type of multi-agent thing. So I've already got a lot of that baked in. But if I were to restate your point, what if you had multiple inner voice focusing on different things at the same time? Yeah. I can run up to 4 with context. With this model, if I switch to 35p, I could run like 8 or 12 at that. But yeah, these are all things that, heck, it's got, it's in front of me, just taking out the time to figure out how to frame it and have the agent set up. But the big thing for me is the benchmark is I have a working hypothesis. We haven't found a good benchmark that would allow us to test that out yet. So that's the next thing that I'm looking at. So until then, I'll continue to dig.
Have you asked it what's a good benchmark?
Oh yeah. Works with Plot Code. Like we've been doing exploring to see any of them that fit.
Or if you could create your own.
And what's interesting is just recently, most of the benchmarks you're looking at is give me your model and then we'll plug it into a random harness and then run these tests. And the thing is, that doesn't work so well. So there's a new intuition that you test out the model with a harness and then you gauge that together. And I have a real world data point to back that up. I'm a big Anthropic fan, even though they messed up like 2 months ago. They're back in my good graces because they made a culprit and they fixed it. And so Plot Code is better.
Oh, they did fix something?
Oh, your tokens are good again?
Huh?
The license,
I
the
didn't
token
think
thing?
The Cloud Code and Opus got dumber for about 2 months, and then they gaslit everyone that said it was getting dumber, and then they finally released a blog post somewhere admitting that they had done some configurations. But so,
Safe.
But did they go back and you could use your plan or Claude? No.
no, you still have to use Plot Agent SDK, which is one of the.
More money than.
Oh yeah, it works fine. You just your agents need to use the Plot Agent SDK to interact with the Anthropic models, and that's what I was doing up until a few weeks ago.
You were using it.
Yeah, and then I ripped all that stuff off and I went.
And you went low level.
Yeah. So Opus and Opus 4.6. At work we use GitHub Copilot, which up until recently had the Anthropic Opus model available.
Oh, and they don't anymore?
It's with a 27x multiplier for Opus 4.
Oh, so
4.7.
where the big criticism about Anthropic is coming in, where they didn't buy enough compute, or they didn't, put the money up front about 2 years ago, 1.5 years ago, and now their big limit is compute.
They were up until they inked a deal with Elon Musk and X.
Oh, right. That's the late breaking.
Yeah, that was
competitors are working together.
Yeah.
Elon Musk, they're buying a huge amount of compute.
Yeah. So to kind of wrap up, agent plus harness is better than auditing just the large language model. Is I was doing some work for work, nothing proprietary, confidential, where I needed the agent to read through this big JSON file and pull some stuff out of it. Now I've been using, I still do use Cloud Code for a lot of this work. I'm like, well, let me see if GitHub Copilot with Opus 4.7 can do the thing. And if it can, we'll just do that. And so Opus 4.7 wasn't either fine-tuned on the GitHub Copilot harness. The GitHub Copilot harness wasn't set up or customized for Opus 4.6 or 4.7. And in this task is let's pull information out of the JSON. Cloud Code handles it really easy. It sees that the file's too large. It uses commands to pull out sections of the file and to store that output to disk and to look on there. Like it knows how to handle large files. Something that I've gotten used to. I asked Opus under Copilot to do the same task, and it erred on the first step. And it was like error, file too large, abort. and that was it, hard stop.
Oops.
Little disappointing. And it just goes to show that when we're looking at evaluating agents, or AI, it really needs to be a combination of the large language model and the harness, because the harness can make or break. The harness is the code scaffolding, right? The code that connects that large language model to the things you needed to do. So when you're using ChatGPT or Claude.ai, that chat interface is and plus the tools and the memories and the skills are come together to form a harness that allows it to do the thing.
So your background processes, are those part of your harness?
And for Lloyd, this mission control, the worker subsystem, the subliminal, all of these tools, plus the tools to do things and the skills subsystem and the memory and the vault, all of that scaffolding comes together in what you could call a harness. And that's what makes the large language model useful to be able to do things in the real world. So a lot of this terminology is evolving. We call it scaffolding now.
Yeah.
Harness is a sweet term. But so when you're looking at it, and I was trying to figure out, I saw a series of benchmarks where they benchmarked the agent plus the harness, but I couldn't find it. I need to find that again. Things are changing fast. Even though Lloyd is not using Opus 4.7 on its own, he's still smart and can code and can follow directions. And because of this harness of memories and skills, he will be useful. So just to wrap up the talk as we go back, stop for a break a little bit. When we rewrote Lloyd for V4, we used the LiveKit UI and we migrated everything over. It's got this fun Aura thing, and the speech-to-speech pipeline works really well. It also has a mobile mode. So when I pull it up on my phone, this is my user experience. And I get full text-to-speech, automatic speech recognition, wake word, just like on the desktop app, with one more little trick that I'll tell you guys about during the show and tell that pulls it all together. So without even having to write the app, write an app for it. Now I don't think it works with the earbuddy. I'll need to check to see how the web app works with my little ear thing. But yeah, there's no reason why, unless I get distracted or redo the framework again, as I'm coming in. It's like, hey, I'm on campus, go ahead and handle parking for me. And you should be able to pay. I know I'm teasing myself with it, but I think unless something else comes up that takes up most of my time, he has the ability to access the internet. You can pay online. He has a skills repository, so he remembers and memorizes how to do things. And we have full speech, so there's no reason I can't be like, hey Lloyd, I'm on campus, pay for my parking, and he'll surface up the memory and the skill and execute the skill for me. With a small credit card, I got from Target, not my credit
I was
card.
gonna say, are you worried about him going on Amazon and buying everything with park in the name?
Right?
You need to code for each parking lot. Figure that out.
Well, no, I think once you pay, it's for across campus as long as you're in the lot. It's just general parking.
Okay, because when I looked at the web UI, it said, and it had on the sign on the machine, it said, here's the code, the 4-digit code for the lot.
Oh,
You have to put that into the web
so I
UI.
have to put that into the skill.
I don't know if there's a table or a list somewhere in their website. And it was actually, that code was 3 parking lots, 2 were far away. And then see the big Cal State Long Beach.
So Louis can take pictures and then put.
I don't have multimedia input yet.
Okay, yeah. Then you just take a picture of the sign and say, "Do my parking."
Yeah.
All right, so we'll wrap it up with just a quick demo. It'll either work or it won't. This is all very new. Hey Lloyd. Hey Lloyd. And we're not doing great. Okay, that's all right. Speed stuff is hard.
Yeah, probably your mic from the Zoom.
Probably, yeah. So, but yeah, I don't know.
How about them in the show and tell?
I know.
Maybe we'll try again during the show and tell.
I got to see it earlier today.
Yeah,
but still.
cool.
But yeah,
Yeah, the club.
the end-to-end speech stuff is still very cobbled together. Still trying to figure it out, but when it works pretty well. And I love that the little thingy that it does. Hey, Lloyd. Hey, Lloyd. No, he's not. Yeah, something's up with the mic gain or something. Okay, all right.
When you're doing the video for the teleconference, you can steal anybody.
Hey, Lloyd. Hey, Lloyd. Hey, Lloyd. All right, no, that's enough of that. Okay. All right. Hopefully I'll have that figured out next month.
Hey, Alan, for the inner voice thing, then what was the bottom line? I didn't quite catch it. If that's like, how well is it helping at this point?
Well, yeah, most of the time there's really nothing to do because most of the time the agent's able to do it. The premature stops, it catches and it nudges. And I've got probably a dozen or two examples of that, as well as the agent stopping before the question was fully answered. Right, it's a bit of a judgment call. The other thing was, since I've gone with progressive tool discovery, if you're interested, I'll tell you during break. Sometimes it doesn't call the tool the right way, so I have something in the UI that marks that in red so I can see it.
Oh, like it had wrong parameter or wrong something.
Yeah, it's
I got that a lot in playing graph as a teacher, or the error message coming back from the tool would tell it, you gave me the wrong parameters. You have to be XYZ. And then the model learns.
So yeah, I'm not sure what we'll be working on next month, but I'm sure it'll be something fun. But yeah, the inner voice stuff, it seems to help a little bit. And as that settles, I'm looking for more opportunities to leverage it, right? Like if you've got a second model that can do something in parallel with the first, how to best make use of that so that the gestalt of it is capable of more things than you do.
So it's almost a little bit like thinking, right? Because thinking, or it's an external, it's a whole other model that's doing some thinking, looking at the response.
Yeah.
Whereas thinking of inside a model, it ruminates about, oh, but wait, I would need to consider this, and all that. That is sort of the internal version of what this inner voice. I mean, that's like an inner voice too.
Yeah.
But having a completely external one, which could be a different model entirely, could have different, a different perspective, almost like a different personality.
Yeah, yeah. So as a person, if I write an email, I look at it for like 5 minutes. There's no errors. I say, Jim, take a look. Like, what the hell do you say?
Yeah,
you say it immediately because you're a different person.
Different person. Different.
Yeah. And do models work that way, or do they not work that way?
They might, if they're different, totally different models. They might.
But if it's the same model with just like a different prompt on it, can it snap its mind out of the?
But we know that depending on the temperature, you give the same model the same prompt, it comes up with a different, slightly different answer every time.
Well, yeah, and even in exercises, even in Claude Code, writing code and optimizing code and code spells are completely different tasks. So you think like, okay, well, if I had some code written, and if I go back and say do a code review, like, oh, it's fine. But when you ask Claude Code to review the code from the perspective of a code review, it finds things and opportunity things to change, not just difference in difference, but actual real functional structural things that just weren't apparent when I was writing it. So
you want to refactor this?
That's just, yeah. So,
no, I don't want to refactor everything.
Well, yeah.
I wrote it for you.
Yeah. Or like I was giving Bill some news articles about it, and once again, someone's agent erased their entire database and code base, and then for it, like, hey, I solved the problem. I solved the problem with uncompiling code by erasing it. Apparently, it still happens.
Yeah, that can be.
And I had one of those a month or two ago where we were. I was doing a git clean where I accidentally committed keys to my git history.
Oh, that whole
And this was a Claude Code thing. This wasn't a void thing. And then on the Claude Code, it's like, oh, there's some git command that you can use to clean the contents of those commits out of history. I'm like, that is exactly what I want. Let's do that. And then he runs it, and all my config files disappeared. And I'm like, dude, what just happened? It's like, oh, my bad. I thought that command would just remove it from the thing, but it looks like it removed it out of their working directory as well. Let me see if there's any in-memory representations of these, and I'll try to recreate it. Like, this is a real world story. This happened like 2 months ago.
maybe it's like one of those cases where when I program a new bat file or some script, I always put echo for the command, so it doesn't actually do it. It prints the command out. There's a kind of a situation where it's like dry run, what, and then or execute on the real.
I mean, the coding was the pre-compile and testing and all that.
But I mean, yeah, when
System.
you ask, when you ask the agent to do something fairly significant on the command line, it's you might have to do a dry run and then send that command line to an AI and say, is this safe? And then something like that. Maybe automate that so it all just.
So yeah, so I'll keep you guys posted. We'll take about 5 minutes for Jim to set up, and then we'll continue.
Yeah.
All right, thanks everyone.
Thank you.
Okay, so, while Jim is setting up, I see we have some new faces online. Shay, am I saying that right?
Hi. Yeah, that's right.
Oh, hello, Shay. Good to have you at the Robotics Society. You wanna?
Starting from.
Yeah, where are you joining from? How did you hear about us?
I'm in Simi Valley, California. I went to CSU Long Beach and I graduated in 2017. Um, and I'm just interested in robotics, combat robotics, battle bots. I'm just lurking today. Thank you for having me.
Well, you're welcome. Always, yeah, combat bots here, right?
Yeah. Some of our members have done battle bots and yeah. So usually our talks can very broadly. Right now, Alan is giving us a series on AI stuff. Jim is gonna follow up with some hardware, how to minimize noise from your motors and your circuits. But yeah, every month there's a different 2 different talks that in some way are related to robotics. So yeah, welcome. And I also see Luis de la Cruz. Hey, Luis.
Hi everyone. I guess I'll do an introduction too. So, I met potentially some of the members here at City of STEM. I'm an aerospace manufacturing engineer in the day, and then after work, I am a mentor for a high school FRC team. So, never been too crazy into robots, but now I'm building them with the students. So, I'm supporting where I can. I'm just, looking at to see, what this association is about, and possibly network and see if there's any potential, educational ties, anything that we could support in, and then, go from there.
Awesome. Thank you, Luis. We have one of our longtime members, Carl. He also mentors RSC.
Which team? I do Momentum 4999.
3473 Diamond Bar High School. Thank you for having me.
Of course. Always welcome. And Sergey. Welcome back, Sergey. Haven't seen you in a while. If you're there.
Hey, there's your face.
Hey, Sergey.
Hey, Sergey.
Well, I'm busy mowing my lawns, so
I want to see it.
The nicest lawn.
I'm in the PX4 code base, away from ROS 2 for now, and I'm actually working on the path planning utilities now. So it's a lot of work and a lot of interesting algorithms of how you plan the path for mowing your lawn.
Do you want me to add you to the show and tells?
No, not really. I'm not ready for that, but you know, you can see me in the email lists from time to time, mostly
Yes,
on
yes.
HB robotics.
All right. Well, good to see you, Sergey.
Good to see you too.
Jim, are you ready?
Yeah.
All right. So, Jim, take it away with how to minimize the noise from motors in your circuits.
Yeah. Hi. So so today, we'll switch over to hardware and robotics hardware type lecture, with tips on for at least for DIY robots, how to handle it's like for more intermediate to advanced robots, to handle these issues of power to your robot, and for especially for more complicated robots like Big Orange. In this picture you can see there's a lot of different things that eat up power, and you can't even see them all, but multiple single board computers, cameras that take up power, AI cameras like that one on top, eats up a lot of power, and the motors, of course, and then I've been running this for several years with one big battery, and finally I got to the point where things were just not able to keep the power budget was getting overdrawn, and so I'm switching to two batteries now, of the same kind. So to show you part of the story here is Big Orange of this lecture is Big Orange's problem, and that was the CPU kept rebooting, unless the battery was close to full charge, or things would just stop, it would stop working relatively early in the battery's discharge cycle. And here's some of the devices we had. I have OAK-D camera, can eat up a lot of power. The Jetson, I had a separate battery, so that wasn't eating up much power, but it is communicating. And then the battery, the Latte Panda is the thing that is the main computer, and that one has it can go down to 11 volts, but if you go much below that, you're gonna get gonna get bad behavior out of it. And the main battery has a range from 12.6 down to 9 over the course of the discharge cycle, and so that's an issue where you need to handle this so that you're getting the right voltage to sensitive devices. So
We use the term brown out in FRC robots when they drop
Yeah.
off, brown out.
yeah, that's what I said brownout.
Oh, I'm sorry.
Yeah, brownout.
Okay, sorry.
But yeah, so there's also noise. Noise is a big problem with motors, but in this case, it was not a noise problem. But wait, there is also a loose ground terminal I had found, and I found this before, where I thought I had tightened it, and then over time, robot moves and vibrates, and these things can lead to loose connections. So sometimes the problem is mechanical. Every once in a while, check your connections, tighten the screws in the terminals. If you're, then a custom robot like this, I have a power rail with my own terminals that these little wire terminals, and they can get loose, and especially if it's hard to get at them without taking apart your robot, then you may not have tightened it well, or it may have gotten loose. So the combined loads, with the combined loads, the single battery just can't keep everything running anymore. So here's the original, the design, the single battery design, and how it basically is set up. You have I guess I have the battery here is powering a bunch of stuff directly with 12 volt, like the motors, it's directly 12 volt. And then it goes through a regulator to the Latte Panda and the USB port. And right at this point, I had a second battery, small second battery for this Jetson Nano. And then the 12 volt also going directly to Slam Tech breakout. So this system, this setup is just driving this battery down too quickly, and because the OFD can draw a lot of current, it was putting this USB port, pulling a lot of power there, and then eventually causing the Latte Panda to sag too much, and this system was just draining batteries so fast, and I wanted to get rid of this little battery if I could, and combine the Jetson Orin Nano into the main system. And turns out also, oh, here you go, right? The budget, if you add up things, it was, the batteries only handle 6 amp, but it could be up to 5.7, and then with a big load, it could go over. I don't think, the loose ground may have caused some of the big brownouts, because the loose ground means that it's more impedance, and it actually will sag the voltage. It'll draw too much current and sag the voltage. But this system was really pushing it, and there's no way I could have added the Jetson or Nano into this as well without another battery. Also, I figured, okay, it's time to really separate the motors from the electronics at the battery level, and everything will just be, better powered. So here's the overload. 2 amps here, 4.5 amp, 54 watts, and then this is a little aggressive. Maybe the motors were maybe only using a couple of amps. Now, I don't drive the robot very fast, but it was near the limit of the battery and causing it to quickly come down, and then occasionally causing the Latte Panda reboot. And Latte Panda I upgraded, which is to a Latte Panda Delta 3 Delta, which uses more power than my old one, the 2 Delta. So now we can back up and talk about what everybody should do, and that's, you've got to know how much power and in what voltage range your devices take. And a lot of them will have ranges because they have built-in regulators, and we'll talk about regulators in a little bit. And in my case, the Latte Panda is 11 to 15, the SlamTech's 9 to 24. The motor driver has this isolation. I'm going to talk about that, why that's very important for noise abatement, especially for people who haven't done much of their own custom robots. This may have been done for you in a kit that you bought. And then I'll tell you how you can easily buy motor drivers that have this type of isolation built in to prevent noise from spreading to your feeding back through your ground to your electronics, which are on the same battery potentially. So I, used the same battery for a long time successfully and didn't have a problem, and this is why, and I'll explain that. The USB hub is just one that you plug, you buy, that plugs in to a wall converter, and so I use it on a battery power, so it doesn't have any kind of regulator. So I need to regulate that, and that this hub feeds a lot of, a few things that eat up significant power, like the OFD, 2 OFDs really, if I use both of them, and some of these other ones are not very much but power, but that hub has a limit and it needs a steady voltage, or else that, the OD will pull, will kind of eat it all up and or cause a problem, because if you're not regulating, the battery starts drooping, as it normally does as you discharge it, and then you might get some problems here. So if a device doesn't have built-in regulation and it's sensitive to voltage, add a regulator. And it filters noise too. Regulators are your friend. So voltage regulation. So there's 3 different kinds that we commonly use. The buck converter goes down from a higher voltage to a lower. The input, you use that when the input is always higher than the needed output. And I'll show you, the next slide, I'll show you some exact pictures of them. The boost converter is going up. And then the buck boost is what I use here, so that, well, I just happen to, it seems like I haven't seen boost only ones on the market, or didn't look for them, but buck boosts are common, and those can serve both purposes. In fact, well, in this case, it is doing both, because the battery starts out at 12.6, a little higher, and then so it needs to drop it down to 12, and then when the battery's down near the end of its cycle, state of charge down at 9, it can keep it up to 12, up to a point, and it has to draw more current, but it will, this will work, as long as it's within your battery's current limits. And they filter transient noise, which is important. If you're using a single battery for your motors and your electronics, that noise can be a big factor, especially if you don't have some isolation on that part of the circuit. Any questions so far about?
What are some of the brand names you use for these?
Oh, well, here's they're not really well-known brands or anything. I find these on Amazon. This one's a particular, I forget that. Yeah, you can see that it's some sort of not really well-known brand names. But this one, I can't remember this one's. Again, they're Chinese. This could be a Chinese product. This one's of interest because I haven't really used it, yet. But it has a little screen and it's adjustable. You can get this is a buck only, but this one is an adjustable one, which is kind of neat. And for prototyping, or if you're maybe not a permanent install, like these other ones are, set voltages, or like this is the one I'm adding to for the second battery. And that's a 9 to 36 in and out, 12 and up to 3 amp max. And this one was a 5 volt out and input 1224. So that's a buck. And then, so these two are bucks, and this one's a buck boost. And these, go for, they're not very expensive. 15, anywhere from 15, 20, 30 bucks or something, depending on what, maybe not even that much. For this more advanced one with a screen and everything, it's a little higher. But they're really important because for these parts of your system that really can't tolerate noise and don't have its own built-in regulator, you got to check to see. Always check the spec and see what does it say. What is the range of input? If a lot of these hobby boards will have a range of input, which means they have their own regulator, and so that saves you as a novice, because I didn't have any external regulator when I built Orange, and it ran. Then I was like, things are winking out fairly early. The battery's only half full. It's still half full. And so like getting that first regulator and extended the time I could use the robot, at least the digital part. The motors would still run, but the computer shuts down, and then you're like, what good is the robot with no computer? No brain.
And I've read online with the converters, you have to have a lot of overhead, like up against the ratings. Like if you want 3 amps, don't get a 3 amp converter because it's less efficient at that limit. So I'm not sure what the right rule is, but you got to go more. Like I've heard double even.
Oh, you mean for the
Yeah, like
output?
if you're going to draw 3 amps, you get one that can handle way more than 3 amps. Yeah, but I don't know.
Yeah, that I haven't really. I've heard that rule. I haven't really kind of necessarily gone used that that rule myself, but like generally, yeah. Well, we'll see about with this new one how well it works. But like my other one was a 72 watt that I have been using. Six. So in other words, I guess I haven't used that rule. I use the rule. Okay, the battery produces 6 amp, so I'm getting a 6 amp regulator, 72 watts, and it's been okay. But you know, if you get get fairly well recommended or have buck boosts with decent reviews, but yeah, your advice is not unwarranted. If you can get higher, but sometimes it's hard to find the range you really want, and it's way too high or too low, and so um, so yeah, look around and find if you can find something that's up to double. I'd go with that.
I've used the Thompson ones a lot. So I did have one project. There's the big chunky metal ones that look like a massive heat sink.
Yeah.
And on that project, we were trying to boot up an ESP32, and it was like slow to power up once we turned it on. But the Thompson worked faster, and it was really subtle. I mean, it was a few milliseconds, but it was enough to where the thing didn't boot properly.
Oh, really?
Yeah.
On the gun one.
Oh
Yeah.
Yeah. So
I have one that is.
All battery power gun.
I have another. The one I had on the robot is currently is this metal.
I've used
sink.
a lot of those guys
It's
too.
for a golf cart or something.
Yeah.
It's, they use it for golf carts, and it's like waterproof. This one's waterproof too, but this has no sink on it. But yeah. So yeah, question.
Well, I mean, just kind of comment maybe on the side with all the ground return path and sag and everything.
Which one? Oh, this one.
With you just showed the one with the chart on it.
Oh, the backwards.
You have the chart with all the noisy lines.
Oh, yeah, I have it. Yeah, I'm about to talk about this.
Okay, so you did talk about it.
Jim, may I ask you a question? You mentioned feeding USB 3 directly from the battery. And USB 3 consumes, or at least assumes that you feed it with 5 volts exactly stabilized. That sounds strange to me.
No, this well, I can show you go back to the diagram here. This is a USB 12 volt. Well, it doesn't say here. It says in my other diagram. This is a 12 volt USB 3 hub. So it has its own. I guess this is wrong. I guess AI generated that, but or maybe it's a 12 volt regulator. So it's a 12 volt input. So it does have some kind of internal regulator to go down to 5. But it doesn't have a range. It's supposed to be exactly 12 input. There's no published range, so I figure I should give that thing as close to 12 as possible because that's what its wall wart was rated at. It's 12 volts.
My understanding is that these hubs, they do have negotiating circuitry inside. So when you plug in a 5 volt consumer, that circuitry negotiates 5 volts to it. and you can have 12 volts, which in this case will go directly through the hub. And this is where your concern kind of materializes, that if you feed it with 10, 11 volts, it will try to negotiate 12 volts, but it will go through, and of course, OOGD camera will not work correctly.
Yeah, right. Yeah, because this one just has a 12-volt barrel connector that you plug into the hub, and it's expecting 12 volts. So if you don't give it 12, you're gonna get, like you said, yeah, it sounds like it'll try to negotiate and then try to draw 12, and it's only getting 11. It's going to cause some problems, right?
Well, it negotiates with the consumer, all that USB-C,
Yeah,
for example, right?
that's down at the other end of the circuit, obviously, when you plug in a USB. But there's obviously there's a regulator between the 12-volt input barrel connector, the 12 volts coming in, and that circuit for the USB, right? That's in the middle of the hub. The hub itself has to handle that, but so it probably does. Yeah, the point is that hub has its input voltage is 12 volts and 36 watts. So you need to provide that. If you don't, the downstream logic is not going to function right, right?
Okay, understood. Thank you for the answer.
Yeah, and just one other quick anecdote. I heard, I think it was an OD with PoE is 48 volts in their application,
PoE.
but it turned out it was coming in at 47 volts, and the OD was failing. It would just randomly shut off. And I think they said that apparently there was a defect in the board, and they had to change a resistor on the circuit board
on the OD
to fix that. Yeah, so even though you think, oh, it's PoE, because the whole point of PoE is that you give it a high voltage and it'll drop it down. There's a converter, but in this case, it actually failed. So
and if you
it was just like a bulb off,
If you gave it 47,
yeah, it was failing. Yeah, so,
yeah. So that's a case where there are regulators built in, but you better test it. And the bigger the range in the regulator, the better. Obviously, like my Slam Tech 9 to 20 something. That's really nice. So it gives you more choices of battery source as well. But here, this motor versus logic. So motors, yeah. So yeah, we'll if there's any more questions, we'll talk more about that. I'm going to cover a little more about the architecture. But yeah, the motors draw a large spiky current. Return path through ground creates voltage fluctuations that every device see. So this is just an anecdote. I mean, this is an example from the internet. I just pulled from what happens to current and voltage in a DC motor, for instance. It's nothing too specific here, but the return current goes to the ground wire. Ground wire has impedance, which is a resistance to that flow, and the spikes create voltage fluctuations. And if it creates a voltage fluctuation on the ground side, but your nominal voltage is your positive minus your ground. So if the ground moves up, the whole thing moves up. And if you don't have isolation, which I'll talk about now, then all your devices will see this noise, and that can really lead to horrible problems in digital electronics. So yeah, and this is another rule I kind of fit into this, is that if something moves, you need to power it from the battery. Negative and positive, never root. I mean, as a beginner, I very commonly hooked up my Arduino directly to the motor, and without any external power. And it, it works for small little 9 gram motors and for testing and stuff. If you put a load on this that's more than a little bit, you may easily brown out your system, because Arduino can handle 500 milliamp max. For instance, our Raspberry Pi, 1.5 amp, and that's shared with the USB. A stall will brown out the whole board. So this is something, I didn't really know when I was hooking up things myself in a custom robot. I'm like, oh, just plug it in wherever it says 5V, and it works for a while. It may work for quite a bit, because you may not, you may not draw that much current. But then, I noticed jittery behavior, or when the mount got a little heavier, then things start going kind of crazy or not working well, and you're exceeding your current limit. So beginners can get away with a lot of laziness, and then you clean it up. You have to clean it up later. So did you have any comment?
Yeah. So when I do things with motors, I never go through a regulator. I always go straight to a battery.
Yeah.
And so
for motors, yeah.
Right. And the other thing is, your battery has internal resistance, so it self sags. Then you want batteries with like high C ratings. So even though they're drawing a load, your battery will be pretty flat.
Yes. Yeah. I mean, I just bought like these off-the-shelf Talent Cell bricks.
Yeah.
Which I don't know what that C rating is on it. I don't know if they even say. It is a bunch of lithium batteries inside.
Is it a flat
3
12 volt
by
output?
4.
It's a regulated output.
Yeah, no, this is not a regulated output. The USB. So this battery has both 12 out and USB out, which is 5, and that one is regulated, but the 12 out is non-regulated. So it goes from 12.6 down to 9 as the battery discharges. So that's an unregulated battery. What I send to the motors is unregulated voltage. What I send to the electronics now, and at the beginning when I first built this, I had no external regulator. I just relied on those regulators that were in those hobby boards. Then I added one because the regulator wasn't quite as good. Like, it only goes down to 11, but the battery goes down to 9. So I wasn't getting a very long performance.
I guess the point of this battery is rated for 6 amps.
6 amps, yeah.
And that means it's probably like a low C rating, which might mean as you vary the current, it's getting more fluctuations over your voltage.
Because
The internal resistance of the batteries.
Yeah. What is it? Because it's 6 amps.
If it only can handle 6 amps, that means it's probably going to have a sag at 6 amps.
Yeah. Sag and voltage.
Yeah.
Where you mean if it handled more, then it might be a higher C, or
Yeah, higher C rating would have less sag at the same current.
right. The only way to test that with a battery like this that doesn't have a C rating, or it's not published, then you'd have to test, right?
Yeah.
So I noticed I have a meter on my battery, and I can see the voltage dip in real time, and it does dip. But again, I guess, yeah. So that's another reason to upgrade to 2 batteries, because now I'm spreading out over 12 amps
or just better battery, a battery that
better. Yeah, again, the battery.
50 amp battery.
50 amp?
The drone batteries will have
That's what I use.
super high output,
They're dangerous.
like 20, 40 C.
Like 100 C. Yeah.
Well, I don't need, generally, like, I'd only need something like on the truck, on the like tracks. Those are only 4 C, right? Or is it?
No.
Not C. It's 4 S or 3S. But the C is what is the C on those?
It's the current multiplier. So you take your milliamp hours times C, and that's theoretically how much current it can spit out.
Right. So those can handle a fair amount of current.
Yeah, hundreds of amps probably.
Before they explode.
Yeah, so if you're running a low current, if you're running 5 amps out of them, they won't even budge. They won't even
So if
register.
maybe, a typical maximum speed might be 10 amps or 12 amps.
Yeah, they won't budge it.
Yeah. But yeah, for that, I didn't want to have a battery. I'm sure as a beginner, I was only intermediate when I started building Orange. And so I just bought off the shelf battery that said 12 volts and USB.
Yeah,
I didn't care.
You can charge
I
it.
can plug it off the wall.
Yeah, there's a lot of good reasons.
I didn't learn even how to do a battery for an RC car until I bought an RC car and then bought the charger. And then when I first plugged it in, I'm like sitting watching it to see if it overheated, or like you type in the wrong info and you can cause problems into your battery charger anyway. But yeah, I learned about that later. But so yeah, this is something for, you can buy off the shelf batteries and you may have these issues more, and then you may need regulators more, whatever. But that's the path I went with Big Orange. So just to talk about noise coupling, which means which means essentially transfer of noise. If you have one battery and no isolation of your noise generating motor, whatever it is, you could get erratic sensors, misbehavior on your controller unit, and then communication drops, and then crashes. And if you accelerate the motor, I've had this happen where I hit because of that loose ground. That exacerbates all this. So the loose ground, and then the Orange came up upon a little like protector on the floor, a cable protector, and the wheel went off the ground and it started spinning at full rate, and it drew a lot of current, and it even tripped the circuit breaker on it. So that can and it crashed. So yeah, if you go to stall current or stall on your motors, you're pushing everything. And if you have a loose connection or noise, you are isolated, then you're going to have a big problem. And it can look like software or hardware problems, and you might be chasing the wrong thing. So yeah, and why I didn't have noise problems. This is the critical thing that, in fact, I learned a little bit from Sergey over time. He even drew up a pencil diagram of, what Orange might be in the future at the time I had him do that. And then I learned that, I didn't learn this when I bought it, but the motor controller I have has what's called galvanic isolation, which is, on the motor driver with these things called optocouplers, which basically use light between them, and they isolate the motor ground from the logic ground. So the motor return current physically cannot reach the logic side, and you can put your voltmeter on it in continuity mode, and you'll see this is not connected. These grounds are absolutely not they're not connected, they're not continuous. And that is a great thing to have on a motor driver, let's just say. I would prefer to buy ones with that built in. Also, my motors are low noise as advertised, and they probably, I haven't verified, but have capacitors across the motor terminal, and that reduces the noise as well. And then that's better for your whole system. The built-in and then layer 3 built-in regulators on these boards, they filter fluctuations, and they provide, the good voltage to the components downstream, and they also prevent the noise they help prevent the noise from getting in. So you definitely look to see what, if when you're buying boards, if they have that. They usually will for the hobby boards. But as you get more advanced, you may get things that don't have as much, and you need to know the range. So let's go through so grounding. One of the main last things I want to talk about is grounding between batteries. You want to have just one, if you can, connection between the grounds. You need to make the grounds connected. So especially if you're obviously using signals between devices that use both batteries, then you need the grounds tied, but you don't want to tie in multiple places because of this concept of ground loop. And ground loops can cause a ground loop is an inductor. It's a loop of wire. So an inductor can generate and receive interference coming from your motors or other components. And it's like a micro transformer winding or an antenna. And that can exacerbate things. So especially if you loop one wire on one side of your robot and one on the other, you're creating a loop. And you want to avoid that. And I did this inadvertently because I'm like, oh, this signal isn't stable, then I want to just add a ground in there. And I found a few ground loops that I didn't remember even doing as I took apart the system to redo it. So the more loop, the more noise transfer. Twisted pair. I found some old PC fan with twisted black and red wire, and that's why you do it, I guess. Helps reduce that. And then, right, and so you want to eliminate that as much as possible. And then, the low impedance is short and thick wire. Or if it's on the board itself, it's just a small little trace on your board. So that will be very low impedance. And so that's something to look out for. If you ever have that urge to let's make a new ground connection, because you're getting some problem with the level of the signal from your Arduino or from wherever, then think hard about whether you need that and try to get one good or a minimum number of really good minimum number of ground connections. So here's the new design quickly, which is battery 1 is up here, and it goes through the 72-watt buck boost, and that handles the Panda, the Orin, and the Slam Tech board. Might as well just regulate all these, even though they have regulators, but might as well do that to put less pressure on these regulators. And then the motor driver just gets raw 12 volt, and that's from the second battery gives the 12 volt. But this straddles both batteries because the 5 volt logic is coming from the battery 1. But that's galvanically isolated, so you don't have to worry about it. And then the second battery goes through a 36-watt buck boost and then goes to the USB hub, which is now, it's got internal regulation, but it also needs this 12 volt input is regulated. And that handles my servos and then these other devices. So now the budget is much better. Peak 4.6, 55 watt on battery 1 and 66 that's with motors really running heavy. So I would say typical is only 40 watts. So now you're well under. And this just outlines that same information. So the headroom. And the ground bridges have our only USB hub. and then the motor, 5-volt motor driver. And so there's the minimum I could have. I'm sorry, what were you gonna?
I don't know if I'm looking at the same battery, but I think I am. It says it's rated for 3 amps and 6 amps burst.
No, that's not
not
the same one.
This isn't it?
No,
Okay.
I looked this up,
Okay.
many times.
Okay, so the 6 amp is continuous?
Yeah, it's 6 amp battery. Yeah, it's I'll show you the. Yeah, I mean, I didn't look that up I've had it for a few years, but let me just show you the because we're running out of time here. This is what it looks like my power rail in version 1, and you'll see this little line here is where I've cut the trace. So this left half is 5-volt and the right half is 12-volt, and these are with the terminals we call these wire terminals that are convenient for the bigger wires. And so in the new version, I've cut the trace again. So now the second battery is going to be using these for the 5-volt. And then you see I added some new terminals. So there's a cut here. So the second battery's 12-volt will be in like these end terminals, and these here for the regulator. So that's how I reuse this perf board to handle my battery rails. And so here's the final list. Map every component's voltage range and current draw before wiring. Verify which devices have built-in regulation and add where you need it. Definitely use galvanically isolated, non-electric, which means non-electric connected to the control circuit, motor drivers if possible. Power actuators from battery, which I violated this a few times in my, my builds. Keep ground connections minimal and intentional. 1 bridge point. This is an additional advice. I have not really done much, but I try to do it if possible. Wire them together, and then when something happens, look into power before software even, and check connections. All right, that's it. And did you any question?
You say it's optically isolated. Aren't a lot of them? Aren't they transformer isolated? Basically, you have your like a circuit in the front end, and then the transformer on the other end is doing all the converting, and it's high switching, and it's not really optical. I don't think
so. That there is. So I haven't never bought one myself directly, but you can have and I mentioned it here that you can have an electric they call it a electrical isolation, which uses it can use magnetic, which is I think in your case of the transformer, it's a magnetic. Yeah. The information is you're not the wires aren't connected, but you're transferring over magnetic fields instead of a light, but you can do it either way, and it may be built into some systems like that. But I mentioned that somewhere in here.
I used Texas Instruments, which are I think they're based on magnetic rather than optical.
So that's common too, apparently. In fact, the ones in my motors, I'm not 100% sure it's opto or not. It didn't really say in the in the spec, but so mine was Talent. Yeah, my battery is a Talent cell, and it's the Talent cell 30.
I'm curious about the Latte Panda.
This is the
2
one.
amps seems kind of low for that, but
What's that?
the 2 amps on the Latte Panda, that's like
Yeah, that's
pretty good.
At 12 volts.
at 12 volts, right? But even so, with powering USB and all the other
Yeah,
stuff.
because that's my territory, right?
Yeah, like what's the power adapter that goes into the wall for the Latte Panda?
Yeah, it's like.
Is it 2 amps or is it?
The power one that goes into there, I think, yeah, it's at least 2 amps.
Yeah.
Now this is Latte Panda. They have several models. The Latte
Haven't
the Latte Panda, it's called the Latte Panda
Delta
3 Delta power brick. So that 45 watt.
Okay, so it's 3.
Yeah, but minimum of 2 amps at 12 volt. That's stable.
Okay.
That's my minimum. That's why I didn't. Yeah, it can go up from that. Obviously, yeah. This is 3 amps, right? 3 amps is that's their power connector, but I don't want to go below 2. Is my point. It can go higher, but typically it's not drawing that much. You know, it's not drawing at the top. 3 would be the top.
Does it handle your networking stuff too?
Yeah. Well,
Like
I'm
the Wi-Fi?
yes, it does do Wi-Fi, right? Yeah. So it's eating some power there. True.
Or I would just be. I would if something goes wrong, I would take a look at that just in case.
Yeah, but so I mean, with my new setup should be good, I think, because it can handle a lot more with the second battery.
Yeah,
It's been working with one battery for a long time.
should be fine.
So, and things started getting flaky since I upgraded, and the Latte Panda 2 Delta was lower power. The 3 is double the CPU speed and 3 times the GPU, but I don't know if they use the GPU. But so you get that double CPU at a cost of power. But
Yeah.
power isn't that much worse.
That's what's kind of kept me back from the Jetsons too, because the power or so.
Yeah. Yeah, so my Jetson, but my Jetson can be run at different power. So that's why in the software you can tell it, limit yourself to 15 watts, 25 watts, 7 watts. So that I can change by software.
Yeah.
The Jetson Orin Nano, that's another power settings. So I recommend, you should, keep this in mind when you're using these devices that can have modes. So like I couldn't use the Jetson at its full super mode off my little 12 volt battery pack that I was using lately. And I'll probably never turn that on with the current setup, or very rarely. If I would use it at probably the 15, if unless I really need something higher for a brief moment, for a brief period, maybe. But
How does that affect your performance or what you?
your performance will go down, but most of these models are like I was still getting fairly, decent 16 frames a second or whatever. My camera I only have running at 16 frames a second, so it was still able to get me, fairly close to that as far as the doing inference to the device at the 15 watt. It was fast enough. So, for them, and yeah, you have to test it, I guess. Test your model, if it, especially for these are image models. I'm sending a picture down, but I can't send the picture down that fast anyway. So the inferencing doesn't need to be any fast.
Yeah.
There's always, there's a limit somewhere in your system that may preclude needing the higher performance because of some I/O thing. So if you get that working really fast, then you'll have to worry about the power.
Yeah.
So any other questions? Yes. So thank you. Yeah, good questions.
I think the opto isolator you find on all the relay boards. The opto isolators on the relay boards.
And where was the relay board? Or
If you instead of a relay, you use a relay board, they usually have no isolation built into that. So.
oh, you mean for when you have those relays that like to turn on a high power thing from
Yeah.
a low power?
Because the relays can make a lot of noise too, but the
Oh.
installation helps, yeah.
I see. Yeah, if you want to control your garage door with a Raspberry Pi, you use a relay.
Yeah.
And then,
This probably doesn't, I was gonna say, this stuff probably doesn't affect robots as much, but for longer range throws, they do make RS-485 boards, and basically it takes your signal, converts it to a twisted pair interface, and then you put another board on the other side. And so you run your signal in, run it over the twisted pair through the board and back again, and that'll even work with these NeoPixels and things like that. Pretty high. I mean, it's not super high frequency, but it's pretty nice for long throws. So.
and the twisted pair, what is running over? That's a
And then you just run a twisted pair from point A to point B, so that basically keeps the noise out. So
oh, that's a way to
yeah,
keep noise from going from.
yeah. I've had issues like at escape rooms, right? Wires really long distance, and if they use Cat5, the twisted pair usually helps reduce the noise a lot. But you can always use the 485 modules if you need for the long run. Like I said, it doesn't really affect the
It's
robot.
keeping the noise from the
Yeah, it's
actuators.
not an expert. There's a type of noise that comes in, like you were saying with the power wires. Yes,
Like an electromagnetic.
there's a name for that type of noise, but it's that open loop that you were talking about, like
This
the power.
is happening because of something at the at that end.
When you run a couple wires across the room,
Oh,
you
just
pick
yeah,
up
yeah.
all the noise.
Yeah, because it says here, the length of the wire matters in the impedance.
Yeah,
So
the name.
the longer the wire, the more, you're gonna have more impedance
Yeah.
and more issue. So you want to run thicker wire if you can.
And then one other thing, so I did use a boost converter, same thing, escape room. They ran 12 volts over Cat5 across 2 rooms and into a game, and it was having brownout issues. And so I just stuck a boost connector on the end. And you have to watch the current though, because when you are boosting the voltage, then you have to make sure there's no current's going to come over the original line. But it solves the problem. I mean, these modules are so easy to get now, and they really solve.
This was the boost
yeah, it was just a 12-volt boost module.
and that helps isolate, or
Yeah.
or it helps ease
That level the voltage at the game. Yeah.
right.
Yeah.
And then your twisted pair is another way.
That was coincidental. They could have used some other wire, but they just happened.
But twisted pair apparently is good if you wrap
for
the
noise. Yeah.
yeah.
That's why Cat5 is all twisted pair.
Yeah, because it
Common
could be an antenna.
But with the differential, the
Yeah.
differential signal, so that they can float together and it's okay. All that matters is the difference between the 2 wires.
Exactly.
So it's way better for the long transmission.
Yeah.
Which one?
So things like USB and RS488,
Yeah, RS485.
45, they don't have 0 and 5 volts, like 0 here, 5 here. They have 2 wires that like go up and down together. So if they get some stray voltage, it'll be applied to both of them. And it's okay because the difference between the 2 wires stays pretty constant, even though they might have noise induced in them.
Yeah, and ones they do a
Oh,
positive voltage and a negative voltage.
Yeah, there's a plus and a minus. Like your USB has D plus and D minus.
Yeah, +5 and -5.
Yes,
It's the signal. It's whatever the plus signal and minus signal. It
And
converts
it's
it
okay if
back.
they both drift. As long as they'll typically drift together with the
Oh,
same
because
noise.
it's doing the delta, but it's doing the
Yeah.
difference.
Yeah.
Oh, I see. So it maintains that.
Yeah, I think it's called common mode noise. I could be getting that wrong, but
Okay.
yeah, so it cancels
Oh,
that
so
out.
Yeah.
the point is electromagnetic stuff wouldn't affect it very much.
Right, because both of the wires are affected.
They're
the
affected
same.
the same. But that's just, I guess when you twist the
Yeah, that would actually
twist the black and red together, it's a similar point.
similar.
Yep.
I was working on a project recently that had this, I was running 5 and 12, and it was some research online was telling me to not run them next to each other because of the noise from
Oh,
the
5 and 12,
Yeah,
yeah.
from the motor noise traveling over the 12-volt
Yeah.
line can jump. to
It'll
the
jump,
5.
it's induct.
Yeah.
And then it was also saying to run ferrite beads on the wires.
Oh, ferrite beads.
Yeah.
That's those, when you see those things on these like
Yeah.
beads on
Yeah.
cables, that's what that is.
And I guess they clamp the noise somehow. I don't know. It's
Yeah,
it's voodoo
that's-
to me.
Yeah, I mean, it's an inductor, so it filters the high frequency.
Yeah.
But it's an inductor, a good inductor in this case, not like,
Yeah.
inducting noise into your system. Anyway, thank you. Good questions. Yeah, and this is a common thing that a lot of roboticists hit all the time, this stuff. And I'm still learning about it because a lot of times you just buy things and you either assume that, and they know, oh, he's gonna assume, and the hobby manufacturers put it in there, like, this guy probably doesn't know what he's doing, so let's put this regulator.
Just talk to the audio engineer, because they hear it, it's fun. They're obsessed with cleaning out noise and.
Yeah, so it's like, we're lucky, in the hobby world, that most of these things are taken care of. But when you start putting together a bunch of components and a bunch of things that aren't, standard, and new batteries and or raw batteries, then you're into more advanced land,
Thank you, Jim.
All right.
All right, with that, we will break for lunch. Let's come back at, say, 12:45. I will stay here in the room.
Got I've got side by side. I've got a X1C, H2C.
The X1C, was that your first one?
Yeah, that's a great shape.
This H2C is a big upgrade.
Yes, it's bigger and it's got all
Bigger volume and more features.
and expensive.
Yeah.
And temperamental.
Oh, more temperamental.
Yeah.
Oh, it's got
I already ruined one of the current heads.
It's more features, right?
Yeah.
And then the upgrade kit for me is out of stock right now.
Ah, where does this upgrade you to the?
Yeah, my printer's not as awesome as Brian, so.
You can get a vinyl cutter for it,
pretty
right?
awesome. It's just
You
slow.
can get a vinyl cutter for them, can't you?
Why don't they have the laser kit?
Yeah, I'm interested in getting a vinyl cutter so I can make stickers. Be nice, right?
Yeah.
For the 3D print?
I think you can get them, but either that or maybe it was my CNC, but I'd like to be able to cut out so they're very.
Why don't you just do a Cricut or something? Because that's another $300. I mean, your printer does it.
Yeah, I mean, I don't know.
Yeah, that's right.
That's why we do most of the stuff we do, right? Because, yeah, very interesting.
Yeah.
Yeah, it's a lot. There's a laser that will cut through. Really cut through like some metal,
There's some printers that do too.
or just wood.
Not sure about that, yeah, wood and plastic.
Industrial.
Well, there's two different laser sites. There's
Right. But I'm afraid that that's gonna gum up the machinery. It's like too much smoke. You wanna keep this stuff clean, right? Yeah.
Yeah, one of my old printers had a laser. I think they advertised it as a laser engraver. It could cut small, thin materials.
Yeah.
I think it was like, I don't know how many watts, but it was very low power laser. For engraving, it worked great.
Yeah. You get
And that was in your printer?
Or hobby board, and you can make the patterns. So maybe we'll cut them out and make assembled sheet metal. I'm not plywood pieces.
I don't know if it was very low powered. I don't know if
Maybe
it
not even cutting out.
it could, I mean, if it was like a small,
Real
very
thin.
thin material,
Also
it
work.
could cut. But it was I guess designed for engraving. But if you cranked it up and slowed it down, it could cut.
It's still pretty cool.
Yeah.
Okay.
Yeah, I never had one of those. The problem with those is you have to have a good exhaust system if you.
Just
Yeah.
Dangerous.
it stinks.
Yeah. It does.
Stinks so bad.
It's much worse than like printing the PLA or even
Yeah. Oh, yeah.
even
Yes, it is a very distinct
Plastic with the laser.
Oh, yeah.
Not polycarbonate, right?
Yeah. What? If you're melting plastic, it's got to vaporize it.
Yeah,
It's not just melted, it has to vaporize.
No, but with plastic, you have to be very careful.
Yeah, the acrylics smell.
Acrylic, you're allowed to.
Laser cutting
don't want-
won't do it because it's expiring glass.
Yeah, you can't. Which one with ABS? Yeah. Yeah,
It's
there's
a polycarbonate, yeah, laser and polycarbonate don't mix.
They don't
So you go
mix.
out to cutting shops, they'll water jet polycarbonate, they'll laser cut all together.
But I mean, yeah, most people who, want to be safe have a full filtration system and a hose outside and everything.
Yeah, see, it's not worth it. I have a CNC if I want to cut things.
Oh, you have CNC.
Yes. So for the robot team, we did a bunch of aluminum cutting and we went to FabWorks in Ventura. So fast shipping, really fast cutting. It was cheaper than buying the metal than cutting it ourselves.
Wow.
Yeah.
Cool.
Yeah, that's something I would farm out, yeah.
Yeah.
Unless you-
We were just amazed. It came back in a few days.
All right, thank you, Brian, for the cake and the.
Yeah, thank you very much.
All right, next up, Alan.
All right, so one of the things that allowed my talk to go without a hitch relatively today was a solution for something I've been working with for a couple of months. Is Lloyd sits on my workstation at home, and he's a web app that sits on my workstation at home. So when I want to use him here or anywhere outside of my desk, I'm like, well, how do you access that? So up until this month, I had enabled OpenVPN access through my router and installed OpenVPN on my laptop. And then when I got here and connected to VeachNet Guest, they blocked VPN. So I would have to create a hotspot and then reconnect. Like it worked, but there were a lot of little steps and it was very finicky, not something you could explain to your mom and dad. So when I was talking to one of my buddies, he had recommended Cloudflare and something else, and so I did a quick Lloyd search, and Lloyd had recommended that as well as this little tool called Tailscale. I'm like, oh, that has a cool name. What is that? So Tailscale is a really slick, easy, free way to set up a virtual private network between individual machines. So it is by definition a VPN, but it doesn't require you to enable VPN at the router layer or any of that other fussiness. More or less what you do is you install it on Android or Mac or Windows or Arch, by the way. And once you install it and log in, it adds that machine to your Tailscale virtual private network. And at that point forward, on Linux, it stays running resident. I'm not sure about on Windows. And on Android, I discovered this morning that you have to make sure the app's running. Once you have each of your machines installed and configured, they just connect by name with no muss and no fuss. So when I got here this morning, the first thing I did was I got on VeachNet Guest and tried to connect. And for now, please don't tell your IT folks this, but for now, Tailscale is not blocked on VeachNet Guest. So, and everything just works. So, because before that, I'm like, oh crap, I need to set up authentication and certs and authorizations, and then poke holes in my router that anyone would be able to find in 3 seconds because of script kiddies. This works around all of that. So once it's set up, every machine that you have set up is available by IP to every other machine. And when you look at, so it doesn't show the address bars. It's just by machine name. So there are a couple other things that I did because I don't want anyone else to access Lloyd but me. So there are some additional levels of security. I did work with Claude Code to generate a self-signed cert and a client cert for each device. So it's set up that this machine on this network can generate the client cert, and then those are installed on each thing. So there's several layers of security, but the mechanics of it, the Tailscale setup is just a dream to set up. Just figure out how to install it on your device, and then once you log in, all devices that you've already set up and logged in are available to every other device. And it makes things like this, like accessing Lloyd from my laptop here, or or from my phone, just a dream. It just works like second nature. So if you're in that kind of a position where you want different computers and devices to have access to each other without the muss and fuss of setting up and maintaining a VPN, I can wholeheartedly recommend Tailscale to make that happen. As a matter of fact, I'm going to add my Hudson server to the network next, so I can access it and run updates, and even have access to the SSH file shares from here. And then Tailscale handles that all transparently. So I added the link in chat for anyone that's interested. But yeah, so far 100% approval, this solves so many more problems than it caused. That's the way that I'm going to be using Lloyd from now on. And really, I don't see the need to write an Android app anymore. Because once Tailscale is enabled, it just works. This is a web app.
Web app.
Yeah.
I've used ngrok before, which is protocol level tunneling.
And
NGROK, yeah.
Okay.
Similar product, but you run a client on the client machine, and then you connect the app through.
oh, but yeah,
I tunnel the protocol out. Yes.
okay. You have to have this on each machine though, right? So, right, on Big Orange, I have to install or whatever on each device.
Yeah, and once those devices are, you have it set up and configured the Tailscale, they're automatically added into your Tailscale VPN, and then they're available as long as they're on. And in Linux, it's set up as a systemd service that enables on boot, so you get it for free from now on. Android, it looks like the app closed behind me. I just had to relaunch the app. Not sure on a Mac or Windows, but I thought it easier.
I have to test it on Windows. I mean, because like I like to RDP remote desktop into my machines over the VPN has never been hard for me. Like I just used a free VPN service. I have to click a button once a month and then I just had to, like my router all routers have a VPN configuration. You just click on and that seems reasonably secure.
Yeah, it's totally secure. What I was running into was actually two things.
And here
I couldn't, VSNet guest blocks VPN.
Stop working.
And if I've enabled VPN on my phone, my car can't connect to my phone while VPN is enabled. So like for this is far easier and easier to set up.
I don't use the phone, but yeah.
Like I could walk my parents through setting this up. Like the VPN setup stuff is.
So this VPN extends your network. It doesn't replace your network. Because you can still do everything else while this VPN is on. It doesn't block your printer. It doesn't block that.
No, it just manages availability between connected devices that have been added to the.
Oh, that's good because I hit a problem where I was logged into a local Wi-Fi which had the same IP mask as my home one, and the VPN. It took an hour, and I figured out a way. It was terrible. Yeah, so there's can be problems with the VPN because it's a whole network, and it was whereas this is more like peer to peer.
Yeah, and for with the exception of my Android phone closing the Tailscale app, it just works. Like I didn't have to worry about it at all. The only one unknown was whether or not your IT folks blocked Tailscale.
They could block it by looking at certain port numbers or something.
Yeah, for whatever reason, knock on wood, they haven't yet, and if they have, just bring it up to the hotspot.
Like there seems to be a lot. Yeah, it seems like they're blocking a lot here. Like I can't even get out. My Outlook won't sync with my Gmail. I have to use Gmail.
Wi-Fi and networking is hard. I hope one day they aspire to have the same capabilities at your local McDonald's or Starbucks.
They seem to have closed it down here. Like they don't want people. They don't want people abusing this, this free service.
Well, this guy did ransomware, so be careful.
What's that?
They got people
ransomware even worse.
Yeah, and even with their security,
their draconian security.
Yeah, because they're, it's a big target for ransomware people. Like
this latest ransomware wasn't.
That was
it wasn't related to the university. That was related to a third-party software.
It was the third party.
Yeah. So yeah, it did. It scared us, especially when you have all your course materials, the grades, and everything on that platform, and then all of a sudden it all goes down. You're like, oh my goodness.
Slack, Google Docs, all this.
Yeah. Take your stuff off the web. Go back to HDDs or NVMe's.
Right.
Local storage. I'm still a fan of local storage.
So thank you, Alan.
All right.
William, you want to introduce yourself?
Sure, I'll stand maybe.
Yeah.
Okay. So hi everyone. Thank you for allowing me the chance to participate to your great monthly meeting. I come from France actually. I'm here in California to build a robot that will help in elderly care. I'm actually talking to many engineers that are interested in the project, so I thought maybe you guys would want to advise or give opinions or collaborate. So if you allow me, I took some notes because I didn't think I was gonna pitch or present anything. So the context of it all is that in the US only, we have 7 to 12 million people that suffer from mild cognitive impairment or dementia. So some of them are in retirement homes or special facilities, but it's very, very expensive. And others are just at home, and the people the caregivers, so they're taking care of them the best way they can with a patchwork of different solutions to try to help them be okay, right? The main problems basically are medicine adherence and loneliness. So medicine adherence, it has a very strong impact if it's not respected, because it can lead to hospitalization and then being forced into a facility that takes care of them from $7,000 to $14,000 per month. So that's huge. Loneliness, yeah, it's very sad because all persons that are isolated at home, they have no one, they don't talk, or and it doesn't help with their cognitive impairment. Actually accelerates the decline in their cognitive functions. So what's the solution, right? Currently, there are solutions to solve the loneliness. You have a few companions, a robot that's a dog, actually, that's a very great feature of science. Others that are just a sort of iPad on a platform, and dolls even. So my idea is to focus on the medicine, the dispensing medicines with the machine that actually has a layer of visual confirmation that doesn't exist currently, to make sure that the person has taken their medicine. Because a lot of people, actually, if you would believe it or not, they would, even if they have an automated dispenser that said, "Oh, here's your medicine," they would take the medicine and maybe hide it, not take it and say, "Oh, I took it." You know, I don't know if you've been familiar with this type of things, but yeah. So the idea is that the little robot that would be a cute little egg type of thing with a drawer that would dispense the medicines would verify that the person has taken their medicine, would guide them through it, talk to them, be a life companion also, and gather the data in a safe way to provide for the family that could see how their loved one is doing in real time, and also have the opportunity to tap to enter the live feed to connect with their parents. That would be easy, because also there's this issue that if you call your parents, they might not pick up the phone, and you would be worried all day if maybe you're working on something that's important, and the mental load is very heavy. So the vision is that it has the potential to reduce hospitalization due to missed medicine, slow down cognitive impairment with daily stimulative conversations, and make families happier by connecting them in a frictionless way with their loved ones. So currently we're in R&D, so interviewing professionals in the space, different engineers for the technical features. And right now I'm looking for advice, opinions, or collaborations. And the goal is to build a prototype that would validate the product market fit to then raise in pre-seed with investors, venture capitalists. Thank you.
Okay, so does there, if you have a pill in the machine, it's going to only put one in the machine to verify so they don't get an overdose or anything like that, right?
Yeah, so imagine a little egg like this with a screen and nice eyes, like the little doll that we saw for the eyes. Then it would have a little drawer that would open with the specific medicine that the person has to take at this time. It's obviously pre-configured by the caregiver, which would be either the person or the person working in a facility. And I only talked about the personal level, but there's also in the retirement homes, it will help with the workload of the personnel that work with these guys. Yeah.
So then it would have to have some kind of a number saying 10 pills left, 9 pills left, something like that on a little screen or something.
Yeah. I mean, it would be in the app, because the goal is for the person that's being taken care of to not have to do or learn anything. So it would be in the app for the caregiver to see, oh, you're running low. So a notification, for example, you're running low on this medicine, like make sure to order it. And then in the future, everything could be automated, right?
They have to refill it though. I think you're talking about the
Absolutely.
caregiver, every time they visit.
They would have to know the machine's empty if they walk away for 10 days. and then it's out of pills, then it didn't work.
Yeah,
Exactly.
they're gonna be visiting after, you know, the caregivers.
Hopefully they will come sometimes.
No, they're gonna be there, right?
I mean, yeah, and even if they would come once a week, which makes sense for people that are very busy, it would work, or once every 2 weeks, it would work as well. No, like, that's definitely a little feature that would be discussed based on the mechanical requirements.
So the egg would also generate conversation with them, like
Yeah.
just
Yeah.
random
I mean,
stuff, or maybe current events, or
I mean, yeah. So what would be nice is because I have an advisor that's a PhD in AI and machine learning, and he told me that we can have the intelligence learn about like the person, and then it will also be spontaneous in the topics of conversation. It can start. For example, I know that you like art. Well, there is this new exposition at this stage. If you want, I can tell you where to find it in the live feed, or I can show you the live feed in the future. Maybe that would be nice. Or, you know, you like politics, we can talk about politics for 10 hours. I'm not gonna be tired of it. I'm gonna listen to you repeat 10 times the same thing, and I'm not gonna be exhausted. That's nice, right? Yes, please.
What's the telephone system like?
The telephone? Yeah, so the idea is that in the app, for example, the caregiver that, let's imagine it's my grandma that's there, and she doesn't have an app, right? She just has the little egg. I will go to the app and I will call her in one click. Currently, I would not implement outbound calls because I want to test it. Because there's been a little, I'm in a group where people talk about like how their loved ones are handling technology when they have dementia, different levels. And one of the problems is that at night there is a thing called sundowning, where the person that has dementia, she will feel really anxious and bad, and she will call all their family at 3 a.m. to say that, to make up a story that they think is real, but it's not. So it's kind of tricky. Yes. The cost of the it's not really a phone.
it's an app within this egg that
Yeah.
it has a function to receive calls.
Yeah.
But it's not really a phone, like a phone they.
Well, that's not, in other words, they can connect you to the phone system.
No, so
We could do it.
there. I mean, they're really not like the traditional landline phones. Everything runs on internet phones, so it's actually just an internet connection
Oh, okay.
Yeah.
that handles everything.
Yeah, thank you. Yeah, and there are actually currently solutions for such phones that are very simplified for people that have a difficulty with technology, where you have on the phone, there's one screen and there's the 6 faces of your loved ones, the people you love the most of your family, and you would click and it would connect you. And that's a feature that could be implemented in the future, but for prototype, it's a little heavy. It's a business in itself currently. Yeah.
Yeah, I talked to I'm in contact with like rest homes and stuff like that in everyday life, or once a week anyway. And patient security is very important. So there has to be somewhere that if any information gets out about this person or anything, their pills or anything, that's important to keep that isolated from.
Yeah. Absolutely. So there is, of course, the main focus is HIPAA compliance from the start.
Right.
Yeah, definitely. And have a closed circuit and encrypted information. And that's where, yeah, it's a little tricky, but definitely a fundamental concern.
Well, it's a good compliment because some of the in-home services, like visiting angels, for example, they won't dispense medication unless you have it in an organizer. So they'll be there to help prepare meals, dressing, and all that stuff. But they're not nurses, so they can't dispense meds from the bottles. So this would be a good compliment because that service will do a lot, but it doesn't. They can't do the meds.
Yeah, the idea is because obviously you will need a specific type of person to handle like and if there are injections and stuff, the robot will not do it, right? But yeah, it definitely helps fill a gap that exists currently, and
At that time, it was called blockade.
oh, sorry. No, yeah, but I agree, definitely. And so I'm at the stage where we're gonna soon build a prototype. And if any of you guys are interested in furthering this conversation,
So William, we have on our homepage, there's a link there, a button to take you to our Google forum. That's where we usually discuss everything and anything when we are not in person. So maybe that's another place that you can go and post your whole project and get the eyes of the other people that are not here.
Yeah.
But there's a whole bunch of others that can't make it because of distance that are part of the robotic society, and that's where we meet in the Google.
Okay, great. I'll do that. All right. Thank you.
Thank you, man.
All right.
Yeah.
How many show? Yeah.
Yeah.
Go.
Make the
Okay, that's the 2025 one.
Yeah, I brought that up too, I guess.
I don't see him.
Yeah, this one looks more like it. Yeah, so last month we went to the LA Maker Fair. Pretty much all of these pictures are when we were setting up and before most of the people were let in, so you can see like the vast number of people that were there.
Yeah,
This is what our booth looked like at the beginning. Go ahead, Jim.
and you got the floor too, which I was going to use. I couldn't make it, but I hope people have met.
It was a really nice setup, yeah.
That provided?
Yeah.
You could ask for the hardwood floor, but I didn't bring orange, so it was like,
It was nice on the
sorry.
floor.
Still nice anyway, right?
Do they have power if you need?
They have power,
Yeah.
right?
Yeah.
They usually, yeah, they have power.
I wish I knew.
One, like, you only get 15 amps or less.
It's enough to power.
It's enough for all your laptops and a robot charger.
In my balance that whole day, my two projects.
Yeah.
One bar,
And work.
on them. I use a quarter of one battery.
Yeah, the booth was busy the entire time.
30 a.m.
No.
Yeah, you guys must have been tired.
Yeah.
I hope it's 5:30.
Yeah,
It was
I couldn't do it.
it was very busy. And of course we had our new fancy banners.
There's been.
Oh, yeah, don't take the trash can unless it's working. That's my advice.
Oh, but
Oh,
I don't want to see it working.
I brought Batsuda and there were so many people wondering about Batsuda, but that environment is not really suited for Batsuda because it's grass and he doesn't roll well in grass.
So he used the floor then.
Well, he was there.
Get in there.
To get him there.
Yeah, he was there and I forgot to bring trash bags and there was so he wasn't on, but there was a lot of people that had to explain what Batsuda was.
Yeah.
Oh, that's too
Maybe
bad.
a show mode that just limited functionality just
Yeah.
for a show. Yeah.
Yeah, Maker Fair, everybody wants to play with something, right?
Yeah.
She can.
That's
Yeah,
why we
I
have
was-
primitive projects and all that.
I'll bring them.
You're an expert at this, Carl. Just
I'll bring them to the Orange County Maker Fair, and I'll have them functioning there if we decide to go. That was across the street from us. It was a chess club or something.
Yeah, right. I saw.
Yeah, robotics.
It does bring up a good point, Carl. That like if to do this in the future, I might think of instead of maybe Big Orange is there. I don't know, but I'll have it more so that people can interact. In fact, like the small toys I brought, like the balancing robot with a little remote control that you can just hand to a person. That's very simple. That's just as they get a kick
A
out
lot
of
of
that.
people want simple stuff that they can interact with. Like I brought that little dog.
Yeah,
And like
that, bring a couple of these.
Yeah, and so I could bring
it
my
was so wildly popular. I put him away after like an hour because I'm like I cannot talk.
Yeah.
Right,
So I had to
do-
come away, but it
yeah.
was really popular. So there's more people that can share that load.
I had to do that
Yeah.
with, the little thing, you bring, those little things are more popular than, because they're
There's a lot of different
interactive.
people.
Whereas some advanced robot that you have to talk to and especially in the loud environment, it's more of a visual thing, like make it do something yourself but yeah, the interaction, it's like, I think that's why the Maker Faire application asks about interactivity. It's like one of the things they like to encourage.
Yeah, one year when we did it, I tailored it towards 10 to 20-year-olds where they built a little circuit, like a little 555 timer thing.
Oh,
And I had them all breadboarding it. And so they got, a handful of kids got into it, but not all kids want to do it. But that way your booth isn't overwhelmed with too many little ones, but you want to, you tailor it to what you want your age group to be.
you mean little like
Yeah, like if you want little kids, you have to have an area for them to work.
Yeah.
That kind of thing.
That's pretty long. Yeah, I did it, because like 100 years ago, I went to an RSSC demo in La Fuente. Jim Resist was there, I think. And there was all these cool robots. You can't touch any of the robots. So that's kind of the reason why.
And that's very common, like that,
Yeah.
at Maker Faire, Bay Area, the HBRC, they set up all these static robots with just a little sign explaining, but they're all off. Now, I love that as an adult. You're like, oh, what does that do? What does that do? But most people who don't know robots or not already interested, they're kind of like, they don't get as much of it.
Yeah, so
Here's
next,
the big group.
yeah, I need to order a safety vest for Snoopy
Yeah.
and get our club logo
Nice.
released on it.
Yeah.
The counterpoint to that is, and bless you, Dan, in particular, I'm praying about for as long as you could, is I have because there's this whole spiel and there's, safety concerns. I take him out, as soon as I see kids swarm, he lays down. But then part of the thing is like, oh, hey, my dog's friendly, come over and say hi and then you can pet him. And so it's like they swarm and they touch him and every once in a while they're like yanking a leg, like, don't do that. But it gives them like a hands-on experience. And in that case, that hardware is safe. The only things that it can do is to power down or fall over and crush a kid's foot. So you lay down, right? And then, play. And then as soon as it slows up, all right, everyone back up. It's time to get up. So everyone backs up and then you go. And then we got swarmed like every 5 to 10 feet, but it was perfect, right? It gives them hands-on experience. If we had the best in the club, it would have been even better. But depending on the conversation, we hand out a couple of cards. But yeah, just being able to physically interact with the robot really made a lot of kids' days.
You mean they touch the, they
I've
back the
heard
robot
you.
down?
Yeah.
We just vibrate the sensors because you were saying something to somebody because I was noticing they were petting it. It's so cute.
Yeah,
They were petting it, but then I heard you say this.
Oh yeah, that was part of the spiel. There's fans inside that keep it cool. I'm like, okay, so if you like you, he'll purr. So if you put your hand right here, can you feel him purr?
Okay, yeah.
The thing is, we're explaining that dogs don't normally purr. Cats purr.
Growling.
Oh yeah, to your point, so much of our stuff is hands off, but to be able to acknowledge and realize and figure out a way to frame it.
Except for
quickly.
Carl.
Yes, everyone's
all hands off.
I'm sorry, it's the same way. It's the same thing. It's like it's
Carl's
a far
known how to do
more
it.
enriching experience. Yeah, you got me beat by years on that, but yeah,
We're like
it's
all
the same.
bringing out these robots with remote control.
It makes us good because the
No.
stuff I have is fun for the kids, but it's really unsophisticated, But then we have like
They don't care,
AI,
they
like care.
we
They
have
wanna
the
see that.
humanoid, so that mix is really good.
Yeah.
It's good to know. You want to have something that looks really robotic too, and maybe moves if possible.
Yeah. Yeah.
Humanoid or non-humanoid doesn't matter. either way.
We have a lot of powered down robots and stuff.
Yeah, but powered down is less effective.
And I was fully set up to teleoperate Alfie, and he's hotspot or not hotspot, but he hosts his own Wi-Fi network. And while the commands were going across in real time, no matter how much I turned down the frame rate of the resolution in the cameras, I was getting 10-second delays. So it just was not going to.
Did you have you had a hotspot and everything?
Yeah, it's just for the congestion in the Wi-Fi. I couldn't get a frame rate that made it compatible with live interaction.
Yeah.
That was a bummer.
But yeah, they don't supply Wi-Fi at the show really. And
It's just everyone else's hotspots and whatever.
oh, everything is next. It's like being at an airport or on something's bad.
I didn't get to
Or a
walk around.
convention, a convention.
But did you get to see Dee Dee's robot? She's got 3 of the
Yes.
Oh, yeah.
Yeah.
That's
Wasn't
really
there a
cool.
picture of her?
And they have buttons. There's 3 buttons, and it'll tell the joke. Yeah.
Yeah, that's
got a
the-
picture.
That's the,
So,
right.
so
the
Dee Dee's in the home for
scan.
robotics. So she's up in San Francisco, and she does demos a lot for the home HDR.
So she came down.
And
for
she
the-
was at the LA right
Yeah,
across
she came
the
to visit our booth.
Yeah, I recognized her actually. That's one. I'm terrible with faces.
I didn't take a picture of her booth.
Somebody, I saw a picture of it.
I took a picture of the booth, but I didn't get it when she was there. I missed taking a picture of her.
Yeah,
I posted that to the over.
About an hour before open, I took a quick 360 video. I could put up if you guys want to see it. And like, this wasn't even busy. This was an hour before it got busy. We had 5 times as many people.
Yeah, it was busy before
It
it
was,
even opened.
yeah.
Like people were there at 8:30 already walking.
Yeah,
It was a long day.
that event.
People were
Yes.
at 8:30.
That event drew a lot of people. But I don't know. The whole parking situation, the whole loadout, it kind of sours me on that one.
I think it's just sour, yeah, because people, what's that?
All right.
Inside joke.
I'm going to tell you guys a story. So the loadout was miserable. I was at my social batteries end. It was a long day. It was hot. I was irritated.
I used up a week's worth.
And I was already sour because last year it was awful.
Yeah.
And then they're like, oh, you need to walk over to the opposite side of the park through grass and then wait there and maybe we'll let you drive there. So we're shuffling stuff over and no one knows what's going on. And then like 3/4 of the way through, they're like, oh, we have an update. They actually want you to upload in the original area now. And I'm like, we're not going to do that. And they're like, well, but just so you know, you can't turn left when you get out of the parking garage. I'm like, the hell I can't. Like, I'm fired up about it. And it worked out. Everyone's like, the parking people had different concerns from the Maker Faire people. And there was just some weirdness. And so we made it around, we loaded up, we're going home. And Danny and I are both introverts. So we're just like sitting there in silence. I've got autopilot driving, just trying to keep my hands on the steering wheel. Right. And so we're driving home and I'm like, there's a point to this story. So I got hooked up on Midwest safety videos of police cam stuff. It's like real drama. Anyways, something bad happened and these cops have gotten this habit of keeping toys in the back of their car. So if there's a child that has been exposed or to something bad, they make it a point to bring a toy to kind of turn it into a positive interaction. So, you know, for small children that can't even process what's happening, it gives them a chance of being able to be a little bit less. So we're driving home and I remember Danny loves strawberry shakes from Hilltop. So we're driving home just in silence, just like dead to the world. And then I pull into the parking lot and Danny's like, I'm not hungry. I'm like, that's okay. I have this idea. Let's get a couple of strawberry shakes. She's like, I'm not hungry. I don't want one. I said, okay, well, I'm not exaggerating that much. And I'm like, you know, here, we'll just pick up 2. And if you don't want it, I'll just put it in the freezer. It'll be okay, right? So we're driving up and we ordered, and I just start telling her the same story about how I saw cops do this with children. And I think this will help us remember this in a positive light. And then I go off on a riff telling her how, like, the fact that I'm telling you this will have no effect on its effect on you. It's still going to work. So we're just laughing about the whole setup of the situation. Anyways, it did work. We both have positive remembrances of the entire day. It was all due to a strawberry shake.
It was so funny. I literally was like, no, I'm not hungry. I don't have any room. I don't want it. But I really did. I was actually probably really hungry, but was so overstimulated that you just can't even think of anything else. So I'm like, no, I really don't want it. And then I take one sip and I was like, now we know why that we're just children and stuff.
And the thing is, just I was worried because I need Danny's help for this. Like, and deep down inside, she loves help participating, but that whole loadout puts a damper on everything. And I'm like, well, maybe let's try this and we'll see if it works. And when she was telling my roommate Lisa about it, she's like, yeah, we had a really good time. It was just a long day.
Oh, really?
Yes.
Right?
The public had a good time.
It was so funny. You're laughing about it really hard.
No, so now the moral of the story is keep a toy or
Or
Strawberry shake
Yeah.
in the back of your car.
We need someone said they don't want them, they probably just don't know what they actually do.
How many children have you probably heard of saying that, like, no, I don't want to, and then
Right.
the parent makes something, they're like, I feel better now.
Or at the club, we need a shake machine
And what's amazing is you
For
can
me, it
tell,
would be
you
a
can tell the
vanilla
subject
cone.
of your experiment exactly what you're doing and why,
And it
and it
still
still works.
Oh, you mean you, right.
Yeah, I was telling you what I was doing.
Well, that's the-
manipulating you 100%.
Yeah.
It's gonna work, doesn't matter when you know I'm manipulating you, like. You're correct.
That's because it's at a lower level, it's.
That's why we're laughing at.
That's the,
We defuse the situation.
because that's the limbic, because it's the limbic system, it's the emotional center of your
I always
brain.
call it monkey brain, whatever.
Lizard brain.
Limbic.
Lizard brain or limbic system.
I was more for real, I really did okay. But I just didn't know that
That's your-
I actually did.
That's your prefrontal cortex trying to reason.
Your second brain.
It's all pissed off.
Yeah.
And then.
No, this was awful, I'm never doing this again.
I was kind of thinking that.
I know, that's why I did it. It was hard.
I still think there's a good argument for not doing it.
But you know what?
Yeah, load out the shake. Let's go get a shake.
No, yeah. I mean, for not doing the whole thing, because, yeah, as an observer outside, you go, that's a lot of.
Well, I just think we shouldn't arrive at 7.
Yeah.
If we arrive at like 8:30.
Did you guys get?
I mean, now
I figured that out.
You
I was
guys
there.
get there at around.
They need
7?
to.
Yeah.
So they gave us
The window was so early, 7.
yeah, that's what they gave different groups, different sections, and different windows.
Obey that. It's not like really
Well,
not.
they're just trying to manage congestion.
Yeah.
That's
So
why.
you guys were able to obey it, but it was still
But then we
too
were
much.
there.
2 hours.
If it
Well,
was
then
a
you're
long
there
day,
for so long.
it was a long day, yeah.
That's, I wish I could.
No one should
I have
be
the energy.
That's unnatural.
What's the same as last year?
Yeah.
What was unnatural? Oh, the whole.
Getting up at 5:30 is unnatural.
It is.
Yeah.
Remember, the year before, I was at Allen's at 6 a.m. I'm like, nope. I'm usually fast asleep.
Yeah.
2 hours more. Yeah.
Yeah, so, I mean, it was fun. There was a lot of people. We met a lot of interesting people. Yeah.
Interesting.
Yeah, well, and then a lot of people were shut down like an hour earlier. We were the last ones there, so we had all the desperate kids
I
running
know,
around.
but our group
The
was.
last 5
filled with
minutes, there were
people
more of
till
the kids.
very end, till we had to tell people, okay, we gotta shut down.
Shut down.
Oh, so they kept coming. huh?
Yeah, they get desperate when other people start closing and we're still open.
I had a
yeah.
conversation with someone who I think might try to come next month. It was the person who was working as an EMT. He said he used to be someone who worked something with like the SWAT people, and he was I don't remember exactly in charge of something where they would drive in with robots and like diffuse situations so that then the humans could go in once the robots saw like where the weapons were or whatever. And then so he had like videos of stuff like that. And so I was like saying, yes, we absolutely would love to watch those. That'd be really cool. So he couldn't come to this one, but he said that he might be able to come to the next one.
I think Walter was in that show.
Yeah.
We showed.
Oh, that's right, with Mitch, which is,
Yeah.
Yeah, Nick, it's
Yeah.
Film
Mitch.
company.
No, this was in real life.
Yeah, no, I believe.
Oh.
So I was just joking.
Oh, okay.
Yeah,
Sorry.
that's like, yes, and, yeah.
Oh, we were gonna give a shout out about the OC Maker Fair meeting on the 17th or so, I think.
Oh,
it
yeah,
is.
yeah.
About that there's the robot company is coming to show some humanoid and other.
Make your lab.
Yeah, it's the OC. What is it called?
Yeah,
Maker Lab.
Maker for
Orange County. Right, it should be under Maker Fair, Orange County. This is the metal lake, right? That's an old one.
Search for Ethan.
Yeah, so from Ethan.
ETHAN, right? I don't know if it's from him though. These are all old. It's because it's the Maker Lab. Or it is under OC Maker Fair. Oh, I could just go to the website actually. He has it in here, right? For the I'm moving on, I'm on there. Let me just check. Sorry. It's MFOC.
So Faraday Futures company.
Faraday, yeah.
May 17th, Sunday, there's 3-hour meetup, introduce their dog and small humanoid.
Right, because I signed up for it and oh, that's the only one he's got under MFOC. What's it called? The company?
Faraday Future.
Faraday, that was after.
I have to email it. You must have that date.
Oh, right, this is, I'm sorry, it's the Wi-Fi here. It doesn't let you access anything. That's why I had to go here. Yeah, Maker Fair, that one's.
And then in July, they're gonna have a meetup at their facility. See, play with full-size humanoid.
Oh, that's right. We need to, yeah.
Here it is. There it is. This is the one here. Okay, this is their website. Oh, they're doing it on Meetup. So the Faraday Future, May 17th on Sunday.
Yeah, next Sunday, right?
Yeah, next Sunday. So what's cool is this, yeah, this company here, these are real, these are cool looking, full humanoid and
yeah, I guess they're a reseller for AGI bots. They just call them by a different name.
Oh, these are what, something else?
Aggie bots, AGI bots.
Oh, Aggie.
I don't know how they.
I didn't recognize these myself. I didn't know about Aggie.
Wait, what group is this? It's a meetup group?
Yeah, well, this is the Maker Fair OC. But they're in.
Because that's the 3D, not the 3D printing here.
But this is part of Maker Fair OC. It's Ethan's thing. That it's part of that. It's not the because it's at the Maker Lab. It's their new facility. I haven't been. Has anybody been?
Yeah.
You've been there, right? I haven't been there. That's the new one, right?
Yeah, I don't know if you.
I haven't been to the new one. I was in the ad hoc ones they were doing. But I haven't been for a 3D printer meetup. Have you guys been to one?
Yeah, I've stopped by once or twice.
Because it's in Anaheim. You live pretty close to that.
Oh, yeah, it's just up the street.
Yeah, I don't live near Anaheim. So this one looks really good because they're like talking about, well, I guess make it bigger here. Faraday Future will be joining us and bringing several robots, including a chance to understand what they do. And then there's going to be future ones too, more hands-on, et cetera, in the future. But this looks like right up our alley. And Faraday is looks like interesting. Faraday Future. I guess maybe you're right. It's a reseller. I don't know. But they definitely have the support. They have cars too, apparently. But but this is the robot. Yeah, these are the robots. Yeah, the car thing is something else good. So these are, I guess it is, yeah, FF Futurist. Full-size professional EAI? Is EAI? So FF,
So it's making a term to.
yeah, FF Master. Oh, here's the, are all these with the same company, same manufacturer?
Oh, okay. Yeah, how do they special out?
Oh, embodied AI. That's what the EAI is. I haven't really heard that used. I mean,
The physical AI.
yeah, I've heard it embodied. Yeah, I've heard that term, but not EAI. But anyway, that's pretty cool. So I'm definitely going to try to make that.
Yeah, it'll be fun. I'll be there. We'll put a post on our forum and let people know and.
Oh, and for and even like Jim, my friend over here, Jim Rothrock, he went to the Maker Faire at like 3 p.m. and he had a kind of a difficult time parking.
Yeah, the park, they give you QR code on it. And you just scan it while you're driving.
Yeah, the blue lot was full, although the benefit was he didn't have to pay the $65. It was only 30, but he had to like interpret a QR code while driving to know where to go.
And it took an hour to get a spot.
Oh, it took an hour.
From when I started turning into working license, actually I found a spot took an hour.
Because there was
And
everything
it was
was
just
full.
backed up all the way.
Yeah, so it wasn't nice for for anybody that arrived for in the afternoon or I don't even know if people arrived in the morning had a great experience. Well, they had to pay $65, right?
30 to
Or
park
was
in the
it-
morning.
Are you sure? Even the public? I thought
I paid 30.
you paid 30, but that was for us.
Oh, and exhibitors.
The exhibitors
What was that before we started?
Last year I
and if you arrived before 8 a.m. or something.
Last year when I came there, I said I was for LA Maker Faire, and that dropped the price for parking.
Yeah.
It was 65 otherwise.
So it did drop it.
Yeah.
So this year, maybe they did the same thing, but it wasn't clear from the the documents they sent us. And they were like, "We're trying to work out a good price for parking, but we're struggling." Remember that?
Is Orange County Maker Faire same problem with parking?
No, it's the fairgrounds.
It's the fairgrounds.
It's
So
the
it's so
fairgrounds.
much
The
better.
whole thing is a parking
There's
lot.
no parking. Yeah.
It still
okay.
costs, but it's
It's only like it's
like
usually
$25.
$25.
Did I miss something? Is this Maker Faire being discussed going to happen this month?
September.
12 to 13.
In September?
Yeah, September 12th to 13th.
Oh, okay. Thank you.
You were on earlier, Jim, that we're still, I don't know if we've 100% decided if we're going or not, because it's 2 days. So.
I see.
Yeah, we don't know. We haven't.
Maybe split up.
Thank you.
Is there any other?
Lost our MCs.
Yeah. Well, hey, I don't know, that might have, oh, who was that? Who was that lady? Is she or? Is here on a Saturday, all dressed up? Must be for some of them.
That's bad. If there's any more, training out there.
Yeah, I think that's the last,
Yeah. Does anyone else have show and
is
tell?
that the last show and tell? Was that a friend of yours?
Last show and tell?
Yeah, that was the last.
I don't care. Yeah, we're done with showing.
Then
All right, let me go ahead and stop the recording. And we're in